Hello everybody, welcome to another stream. How are we doing? KDE has updated and messed up my yeah, it's just messed up my monitors. There we go, that's a bit better. That one used to be green though. Yeah, hey, I hope everyone's doing good. Green for memory. Maybe a bit brighter, but these are a bit too bright. Maybe that's alright. Yeah. And then I had another one. So I had CPU usage. Oh, then network. That was the other one. Yeah, network up and down. Yeah. Perfect. This is the way. Cool. Got that up and running now. So, yeah, last stream was getting the text. Improving the text rendering, but we also improved the theme, so it's now black and white, and so it's a lot nicer on the eyes, basically, and a lot less margin and padding. So we want to improve the font rendering, so we started on that last stream, and we want to basically get rid of this fixed font and make one we have this other glyph cache, which is just uninitialized memory at the moment, but it will have memory in there soon. Proper memory, glyphs and stuff. Hey Glorious, how you doing? What's up? Yeah, not bad, not bad. Got a nice long weekend. It's a bank holiday weekend, so I got tomorrow off. So doing pretty good. How about you? Went to a party yesterday and ate a load of sweets, which was a bad thing, but it's cool. Got this Dr. Pepper as well, but it's not the sugar-free one. No. So, whoops. But yeah, how's the Vulkan stuff doing? Because you did the custom allocation. Did you get all that finished in the end? Doing some BS for uni, so crap fun. Yeah. Yeah, I know what you mean. Yeah. Yeah, do you, obviously you do computer science at uni, right? I remember those days, like Java, OOP. Right. So let's record a little bit of an intro. That'll be good. Bum ba bum ba bum ba bum 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 bum. Man, this text view is gonna be amazing. Or it already is amazing. Right, can I open this up in like a yes and get the quick brown fox jumps over the lazy dog. There you go. Yeah, program engineering, interesting. Engineering. Well, at least when you're done with it, it's a thing which helps you get a job. So, but yeah, I do remember the times it was super stressful for me too. Yeah, very sad state of affairs education at the moment. Right, let's drop one of these markers. Hello everyone, welcome to another devlog. So today we're going to carry on with the glyph cache rendering. This is the font that we're going to get rid of. It's a fixed size 10 by 10 pixel glyph for each character. Words. Hello everyone, welcome to another devlog. So last devlog we started on the font rendering and we also improved this theme here. But today we're going to carry on with that and hopefully complete it. So this is the old 10 by 10 bitmap font, which we're going to get rid of and replace with a dynamically rendered text. So here's the glyph clash texture. It's currently uninitialized memory, so it's just a bunch of random pixel data. And here is the font we're going to be using, Liberation Mono, and we're going to be rendering a bunch of different sizes into this glyph cache first, and then we'll actually try and use it from there. So let's carry on with trying to get glyphs in this glyph cache. Cool, that's a good place to start. So we should probably start with these guys, right? Let's just initialize these things. Well, no, we should do initialization code last, because we don't know how the algorithm is going to be implemented. Right. So last devlog we made these 5 arrays and a couple of hash sets actually. We are going to now write the code which actually implements. Oh, my days. What should I say? We are gonna. Right. Okay, so last devlog we made these these 3 stacks and 2 hash sets. We're going to go ahead and write the implementation code and save the usage code for last, just in case we end up changing some bits around. So let's go and do the implementation code now. Yeah, I don't know, should I include that? I don't know. Yeah, still more time. Right, so here we've got a few stacks and a couple of hash sets that we made end of last stream. So we're going to go ahead and write the usage code where we actually use these, fill them up and clear them first, just around the whole algorithm, and then we'll that we went over last time, this thing here, this whole plan. And then we're going to go ahead and do the initialization code afterwards, just in case we end up changing, getting rid of some or adding new ones. Right, let's go. Well, I measured some performance with my arenas and with new driver allocator, and it basically was about the same. So I sort of paused custom allocator until I get some more complicated Vulkan stuff going, then measure, decide it was worth it, I guess. Yeah. Interesting. Yeah, that's a bit bizarre. Yeah, because they use a bunch of mallocs under the hood. But I guess it becomes a problem when your application is... So when the Vulkan instance boots up, it's probably quite cheap malloc, I imagine. Because it's just... It doesn't have to search far. Linux audio. Anyway. Yeah, I imagine malloc is best at the start when you start the application. So when you have an application that's running, malloc is probably going to be quite bad when there's been a bunch of little frees in there. Where it's got search over. Yeah. Right. 2 seconds. It will be back. There we go. Maybe they have two copaths and driver. One's their custom allocated, possibly arenas. Other for callbacks are passed. I don't know. Potentially. But then you've got like many different places where the callbacks get called, and that could get quite difficult. Maybe. I don't know. Yeah, maybe. Okay, so the plan is we've got to change this draw function, draw text function, where we go over each glyph, where this is for each glyph. Try to add an existing glyph. So that would then be core hash set, find or insert. Then, so that'd be GUI dot. You try to add it to the glyph cache. Styled glyphs in cache. Styled glyphs in glyph cache, hash set, something like that. Right. And then what are we looking for exactly? Some style. Okay, so we need to make that styled glyph. Style glyph. We've got to be careful, it's got to be zeroed. Because otherwise the hash function will bugger up. So the glyph index. So we have to get a glyph index as well. So the font is going to come from the style. Oh, we haven't put the font in the style yet, have we? Text line height, UI font. Yeah, we'll get one of those. Right, so we need to use stb true type, and we want to locate from I think it's got like a code point glyph index from glyph. You know, we just have to get in there, and so it's like glyph index. Okay, find glyph index. This is that. On the same character you want to speed up, call this function with the character you're going to process. Yeah. It might be worth caching the ASCII ones, to be honest, because they'll be the most common. But yeah, I don't know. They frequently allocate a bunch of stuff and then free all of it, and then did it all over again. So it's kind of similar to arena usage, where you just reset size to 0. Right. Okay, interesting. Yeah, I imagine they've got some smart people working there, so maybe they just hook every single allocation into that allocation callbacks. So we want to put in the font, so GUI fonts. Then what goes in here? The code point. Alright. The last thing is the line height. Pixel height. So maybe we should call it line height. It's probably a better name. Okay, so here we'll say style text line height. So there's our style glyph. Wait, what did I do? Oh, right, okay. So you probably want to, do you want to do like a round or a floor? How do you, probably just a floor be fine. Should be right, it'd be a truncate. So after you got your style glyph, you see if it goes in, can be inserted into the glyph cache. Why is it by value? Oh yeah, because you do it manually by pointer if you want. Okay, that's fine. Okay, so we first check to see if I can insert it into the glyph cache. Then it'll tell me or insert. Then it returns a boolean to say is new. So if it's newly been inserted into the glyph cache, then that means you're trying to add it to the existing glyph cache. If it gets filled up, mark it as blur all away. So you can mark it as blur all away. Wait, there's an issue here. It has to be a find. Right, hash set find or insert. So I believe you can never insert into a full. Yeah, hash set is full. This is a problem. So there's two ways you could do it. You could say if it is about to get full, or just say well, that's the hash set. The hash set should be big enough. No, it should just be big enough regardless, I think. The hash set isn't a problem. So if it's new, we've then got to add this glyph into the glyph cache. So where is the glyph cache? Like, are we gonna have the texture or CPU side and just sort of render it into that? I don't see the problem with that. Just having a mirrored version CPU side. It's only, I don't know, it's not that big in size, right? It's 2k squared multiplied by 4 bytes per pixel. So it's about 16 meg of memory. Shouldn't be an issue. But yeah. Let's just make one of those there. So let's make the texture here. So let's say it's called color 32 glyph cache. Texture. So what we can do is now render it into here, I guess. So we've got to get the actual rectangle. I think we had, we need one of those sort of STB, because we're going to use our rectangle pack thing. Did we actually get that included into the... No, I don't think we did. Did we not download it? Yeah, we did. Cool. So the basic idea is we want to... I guess we'll pack one rectangle at a time when you're just adding new ones. Well, no, this will come later. You don't do this yet. You just say, yeah, you want to give back. What do you want to do? Right, how do you handle this one? Did you play all of the style glyphs into 2 arrays? All existing ones in the glyph cache, and just for the new ones that were added this frame. So yeah, the style glyphs added this frame. So you want to put that into a lovely array. So it's be a core stack push GUI.this. I'm going to push on this styled glyph. So this will mean we have to add all of these rectangles, or these style glyphs, give them rectangles, and give them a space on the texture at the end of the frame. They can get packed in together. And then we can patch all the render code later. So, right, what else do we need to do? So now you've got them, you don't actually need... That's in the hash set. But this needs to be deduplicated as well. Um, I wonder if we need the second hash set. Because we just need to add it to the glyph cache and then just put it on the array. Yeah, new was this frame. I don't think we need this second hash set. I'm going to delete it just in case. We only need this hash set to say which style glyphs are currently in the glyph cache. And these are new ones, pending new ones this frame. So, right, we have that. What will be next? So we now need to add the glyph. Right. Store pointer to draw the glyph. Right, when we draw using this glyph, so we can patch it later. Right, so I guess we could skip this code for now since we're not going to be changing this. So here we do the drawing of the glyph, and we say it's the shape of a bounding box. We then color it in with a glyph, passing the glyph ID. So for now, I think we should just say, yeah, we'll just skip this. But soon we'll instead keep track. When we say color glyph, I think we'll keep track of the word it pushes on, where it has the reference to the glyph ID. Then that will get patched later. Since it's all published UI draw code, and then we can yeah. So I think this should be good enough for now. So all we've got to do is go to the end of the frame and blow it all away if it needs to be. How do you know though? How do you know if it's full? You don't know if it's full until you try and pack it the first time. Yeah. You have to try and pack it. If you can't pack them all, you got to try it again. Okay, so that's good. So I think we go to frame end. So now we need to do a thing where we say, so we want to go over all those new ones that were added this frame, all of these guys. So do a nice glyphs. What is it going to be called? New this frame count. So just get those boys and girls there. So core stack count. All right. So we're going to do a nice for loop. So the glyph index. Well, it's probably this is say index. All right. So you want to get your styled glyph. You want to. We've got to produce rectangles and things like this. So we need we need to temporarily allocate a bunch of rectangles. So we can do that. Glyph rex. So you need to be able to you actually probably need the rectangle to stay around, thinking about it. Yeah, it would be decent if they need to be in an array first. So we're going to say core alloc an array of rectangles, and we need this many rectangles here. Now, huh? Oh, I need the custom allocator. So the frame allocator, so that's just a linear allocator. Right. Okay, that's good. So temporary allocate these, will fill in. So I think you need to fill in the width and height, right? Yeah, width, height. Pack it and then render it. Or yeah. So we need to say get the rectangle. The rectangle is going to be so an STB true type. There's a way to get the box. Glyph. Glyph box. So I think you can use this, take the difference of these two, and that can give you the size of. To see where this is used quickly. Get bitmap subpixel. Box subpixel. This might be the better one. Right, scale, shift X, right. So I wonder where's the packing code that they do? It's here, isn't it? Yeah, this is it. Yeah, this is basically what we want to do. That's the code. So there's the font size, line height in pixels. So that is, we need to get our glyph. Wait, where is it? UI style glyph. Style glyph. This is just an integer, so it just comes out nice and easy. So it's just a 64-bit uint. It's like a union. So it's just got a bunch of bit fields. Yeah, it's just a 64-bit uint, basically. So we want the line height. And the info here. So I guess we can get it here locally, I guess. STB TT font info. So it's the address of GUI fonts, styled glyph font. Cool. So you pass in the font info in there. So get the scale from a pixel height, and then from right, and it uses negative for the EM mappings. We don't need that one. We just get rid of all that there. So now I've got this thing called a scale. We call that I don't know, font scale. Let's call it scale, I guess. So this glyph that we're passing in, I think that's the glyph index, my understanding. Yeah, it's the glyph index. Yeah. So that's in style glyph index. Scale, we're not doing any oversampling, so we get rid of that. This is the shift, X, shift Y. I don't think we need to do that. And then here's the yeah, we just want all of these boys and girls. This is the bounds of the box. Then we take the difference between them plus any padding. Yeah, so this needs to be a constant. So we should stick this probably in the internals. Well, yeah, just in the internals. So glyph cache, glyph padding. Just call it glyph padding. So this is probably going to be like a pixel, maybe 2 pixels, but we can change it. That's the point of it being a constant. So yeah, we just want to say plus any of that there. Cool. Great. That's super nice. So that now goes into the rectangle. So you get the rectangle here. And so just be rec. We only need to set the width and height. And there we go. So after this, we can now go ahead and do the continue to pack into the glyph texture. So we need one of those RP contexts. We don't have those, and it needs to be instantiated also. But we'll do that last. So here we're going to put one of those RP rectangle packing contexts. So rec pack rectangle packer. So we'll call the STB rec pack pack rectangles for us, please. Oh, pack those rectangles using the GUI rec packer, and we are then getting all those rectangles, glyph recs. Then it's styled glyphs new this frame count. So that's going to go ahead and pack all those boys and girls in there. Now the issue is, I think not all of them will be packed. So it returns an int. 1 if all rectangles were successfully packed, 0 otherwise. So here we say boolean has packed all recs. If it has not packed all of the rectangles, then we are going to repack. We're going to blow it all away and then repack everything that came in new. Wait. Everything that was used this frame. Yeah, that's the thing. Used this frame. We've got to get that. We don't have that at the moment. Let's quickly get that. So every time we try to draw a piece of text, we go over every single glyph, make this styled glyph, see if it's in the glyph cache. If it's not in the glyph cache, we go in here and push it onto new this frame. So I think we want to say if it wasn't new. No, I think you need, yeah, you need a hash set. This does need to come back. I forgot what I called it now. Bring it back. Style glyphs, new this frame. Yeah. So has, right. So I think we do need this, and maybe we'll start off with it actually. So then we say, yeah, we'll do new this. We'll try and insert it into the hash set for the one which is saying all the glyphs that have been rendered this frame. If this glyph hasn't been rendered this frame, then we also try and see if it is not in the hash, if it's new to the hash set. If it's new to the hash set, then style glyphs new this frame. If it's new to the hash set, then new to the glyph cache. So we need two arrays, right? We need one array where it's all of the new glyphs that are being added to the glyph cache this frame. Then we need one array which is all of the glyphs I wonder if you need it in a, we could use a queue and just, push on the back, push on the front. But yeah, we need two arrays basically. We need so if it comes into here, because styled glyphs this frame hash set. So we check to see if the style glyph has been used this frame. There's a new this frame, and there's a this frame one, something like that. So regardless, it goes on the this frame one, but then sometimes it goes on the new this frame. Yeah, something like this. Yeah, so now what two arrays. So we try and take all the new ones that have been added to this frame, pack them in. If we can't pack them in, we then try this. We try this again, but we try it this time with all, yeah, so maybe you could do this in a for loop. So it tries two times. The first one Hey Dora, how's it going? How you been? Happy Sunday. Happy Bank Holiday Sunday. Got the day off tomorrow. Oh yeah. Styled glyphs. So by default, we'll try the new ones. Then if we fail, right, so we say, what we probably want to say is, if try equals 0, then we're going to make that just all the style glyphs that were added this frame. And try again. Yeah, no, we'll do that regardless. So this one is saying, I guess, we assert that try is equal to 0. So basically we've, failed to pack all glyphs added this frame, even from scratch, even using an empty glyph cache. Empty glyph cache. All right, so so you get this right. That could just be a copy like that. Guess you mark it as const to say, don't change this memory. That one went up. All right, that is good. So here, oh no, it does need to get changed. Yeah, I need like a slice, but I don't have slices. How's the OS stuff? It's going alright. Just, yeah, trying to get this glyph cache logic sort of sorted out. But yeah, it's going alright. I'm just, the theme is looking good. A lot less crazy. But yeah, it's going good. All good, man. Monday already here. Yeah, I know. Happens, doesn't it? What's crazy though, to me, is my wife is going back to work on Tuesday, and she's been off for like 10 months. So it's kind of funny because I remember when I said, like, I think when she was like 3 months into her maternity leave, I said, you've got like hundreds of days left right now. It feels like forever until you go back to work, and now that forever has been. It's a long time. It is kind of nice though, because the baby's all, a lot more grown up than he was, a lot less fragile. So it's great. So if we fail to pack, we want to memset, I guess, success, failed. Success will then break. So we've got to actually do the rendering here. And here's going to try again. And we'll be like, oh, I'm going to memset everything, which in GUI.glyph cache, texture, transparency, just complete darkness. And then, well, Yeah, that'd be fine. Then what else will we fancy doing? The whole size of the texture. So it's UI glyph cache dim squared times by size of color 32. That's 4 bytes. Like that. Yeah. Well, I have got my core 0 element thing. 0 array. 0 element many. That's legit. There you go. So it's just going to 0 that and try again. Yeah. Then it changes out to these styled glyphs that added this frame, not the ones that were new this frame, all the ones that tried to get added this frame. The deduplicated set. Packs them on success. And this is where we, on success, we do the rendering. So the rendering is done on CPU because, yeah, that's what the library does it on CPU. So rasterize, there's a function for that. So I don't think we use this one directly. I think we use one of the ones that calls this. Yeah, get glyph bitmap subpixel. I think use this one or use one of the other ones. Let's just find what other things do. It's got some built-in packer. Pack rate, pack rex. Right. Render into rectangles. This is it. Right, make glyph bitmap subpixel. Okay, we'll use this one. Right. Out width, out height, out stride. Interesting. All right, let's take a look into this. So, give the horizontal metrics. Get glyph bitmap box. Didn't we? Okay, we already got that, but we need. What do we need? I'm wondering why it does. So it does the rasterization here into the texture. Yeah, I understand that, but then why did it have to do it again? Right, to get the X off. Right, these things. Okay. We don't need that just yet. So let's just get this guy. And we'll, right. So we've got to remember to add the padding. If not, it's going to be a problem. So you've got to say... Yeah, so these rectangles would have been packed now. So you need to... So they've got their X, Ys, and that. Yeah, so you want to loop over all the... It's not new, this frame. Cool. So you loop over all the styled glyphs and probably the rectangles as well. We definitely need the scale. how complicated is this? It looks quite free to calculate. That's just, I guess there's a division in there. But probably shouldn't be so bad to do that. So we want to get the... Right, I need the style glyph actually. I need the font info. Alright. So this is going to render the glyph into the texture. Wait a minute, I did a full color texture, didn't I? It renders a, it's just, obviously it doesn't render color, right? Just an alpha texture. So that was wrong. Just 1 byte. Even better, less memory then. So that's, yeah, it's only 4 megabytes of memory then. That's not bad. So pixels are here, so it's GUI glyph texture, glyph cache texture. The rectangle, so we've got to offset these a bit. So we want to get the, these are just units. Yeah, they're just ints, I think. So we're going to say x equals rectangle x plus the glyph padding. Wait a minute, this has got to be glyph padding times 2 when we pack it in. But yeah, we're going to add glyph padding to that, y, and then we're going to, for the width, it's, wait, no, we take away here, and take away times 2 for the width, and for the height, take away times 2. So, I guess you say plus x, y times the stride in bytes for a row. So that is simply glyph UI glyph texture dim. Now the width, height, there's no oversample at all. Stride in bytes to the next row. Scale, none of that. And then the glyph index, so that's styled glyph, glyph index. Right, that's pretty decent. Yeah, I didn't, yeah, sweet, save it. Cool. Right. So I think this is basically it. Yeah, so I think this will basically render us all of the glyphs into the glyph texture. We're just not uploading it to the GPU yet. So what we should probably do, let's just see if it will run. We can also print out some information, I guess, to say rendering, or we could just go through it in a, could put some breakpoints. Wait a minute, we need to initialize all our arrays as well. Yeah, so initialize the arrays and hash sets. We also need, yeah, let's initialize the arrays and hash sets. It's not everything. So which ones are we actually using? So we're not using the patching ones yet. Need this frame. Okay, let's just copy all that. UI in it. So, sticky harassment. Kind of loud. Boom. So, right. Oh yeah, we need to reinitialize the packing context in that frame end thing we just did. If we fail, and try again, we need to say stb rectangle pack initialize target, and we need to pass in the context of GUI rectangle packer. Take the address of that, please. Followed by the so the width height is dim. So square texture. The nodes. There's a way to get the max number of nodes, isn't there? But yeah, we need the nodes as well. So node, all the nodes, rec packer nodes. So what's the maximum number of nodes again? Nodes. To guarantee best results, either one make num nodes equal greater than or equal to width, or call out of memory defined below, or allow out of memory. Right. If you don't do either of the things above, widths will be quantized to multiples of smaller integers to guarantee the algorithm doesn't run out of temporary storage. Okay, so we'll just make sure it's equal to width. Easy peasy. So we'll just pass in the GUI dot rectangle packer nodes. So we'll initialize those. Hang on a minute. Oh, yeah, the number dim, and voila. So we'll copy that, and in UI init, we're going to do the same thing here. Just plop that in there. Right. So that's the packer initialized. We also need to initialize the nodes. So that is going to be, where's the static allocator? Yes. So GUI dot rectangle packer nodes, core alloc array of these rec pack nodes. Okay. And we want that many of them. Oh yeah, with a static allocator. What? Right, so there's those two things done. The glyph cache. So with the glyph cache itself, this is a CPU side representation of the glyph cache, and we'll upload parts of it to the GPU at a time. So we've still got to write that code, but it's not too much to add on. So what are we doing? What are we doing here? We want to allocate an array of bytes, which is dim squared, and voila. These guys here, these patch glyphs to patch. We've not used these yet, so basically we need to figure out like what's the maximum number of glyphs we're going to be able to store inside this glyph cache. So let's just say the smallest font we might have is 8 pixels. It's not that, but let's just say it is. It's obviously going to be bigger than 8 pixels, but we need to over allocate by something. I guess. So what I want to say is like we can make this a lovely constant, right? Glyph's capacity, right? Let's just say, yeah, and we'll say what is the smallest glyph? Glyph min height, obviously in pixels, it's 8. So I think we want to say, so given the glyph cache dimensions are 2K, so we can just use one dimension. Let's just say it's a square glyph that we try and draw. Is 8 by 8 pixels, and that will tell us how many glyphs we can fit along one dimension, but let's just say it's square, so it would be 2 dimensions. So that's the maximum number. Wait, is that right? Or do you want to... Yeah, I think you want to square that now. Is that right? Do you square that? So that's going to be... Yeah, obviously you square it. Sounds about right. So divided by 8. So you get 256 along one row, right? And then you square that number, and it says 65k glyphs that we can fit in. Yeah, did we handle the case where we fill the... Did we handle the case where we fill the glyph cache? Oh yeah, we do, because we won't be able to pack them all in there. Yeah. So you square this result. And voila. Alright, so basically, all of these arrays use that constant. It's got to get that constant again. Where is it? Glyphs capacity, the maximum number of glyphs we're ever going to have. So I think what we'll do is we'll say, well, if a glyph is like so small, we're just not going to render it, and that will be the way we get around that. Yeah, the way we get around the problem where there's too small of a glyph, or many too small glyphs that end up overflowing these arrays and then crash the program, right? That will no longer be an issue. So we've got all these lovely arrays initialized. We have to get the hash sets initialized as well. Right, do I want to... I feel like yeah, I think I should record, before we carry on, I think I should actually record. You know, let's finish the initialization code just a second, and we'll record it in separate steps. But I probably need to record what we've done so far. There's another one called glyphs to patch. Right, so then we need to fill up these hash sets. So the hash sets need a key compare function with that styled glyph. Yeah, so we need, I forget the prototype for this, so we're just going to find that quickly. All right. So key hash and key compare. Right. Let's just drop these in somewhere. So UI styled glyph hash UI styled glyph compare. Oh, right. So let's initialize these boys and girls. So how are we going to hash this key? Well, the key is just a U64. But yeah, we'll get the style glyph. So basically I want to fetch out the raw value from that. Oh yeah, so I need to return fnv hash 64. The bytes are going to be passed in, it's just going to be a 64-bit int. Well, I guess we can just say passing key size of that. But got to make sure that the memory is 0 though, so all the extra padding bytes are 0 too. Wait a minute. That initializes every element to 0. Yeah. We've got to do mem. To be technically correct, this has to be, because that will initialize every element to 0. So it might not work. Technically, we should be using 0 element. That'll work. 0 the padding bytes, since this is used in a hash table, right? Or as this is hashed. There you go. So we hash passing the initial key. You have an initial value for FFV hash and it's not 0. Some prime number, some big old prime number. Yeah, so that's how we're going to hash that key. Then how we compare the key is we simply return the compared A raw with B, like so. So there's our two lovely functions. That's where the pointer goes. There we go. Right. Cool. So, oh, we didn't use the hash function. Whoops. Ooh. Right. So apparently, I've got a way to customize the hash function. That'll be passed in when we create the hash sets. What's the third one? Oh, the initial hash. Right. 0. This feels wrong. Yeah, maybe my hash tables aren't getting initialized properly because of this silliness. Yeah, we should probably remove that custom hash function maybe, unless there's a value where you can say hash initial. Yeah, should have a think about that. Because that probably won't be ideal for performance. Not a legit FNV hash then. Right, we'll look into that some other time. Yeah, so UI init. Let's just finish up initializing those. So we need a new one called hash set initialize. Yes, we pass in, so we want to initialize the ones this frame. The allocator is a static allocator. The hash function is core FNV hash 64. The key hash function is UI styled glyph hash. The key compare function is key compare. Then, am I missing a capacity somewhere? I think I am. Yeah, capacity. Right, so the capacity, you should probably do, I forget how this works again. Is it capacity, right, so power of 2. Yeah, it's power of 2. So we'll just let it do its thing. We'll say, hey, we need this many, and it'll round up to its power of 2. Yeah, we'll stick with that one. So, cool. So that should be everything initialized. Let's give that a go. So we run the game, crashes, and it's saying out of memory. So we've finished our linear allocator. So that is, I forget where that is done. Oh my days, such a terrible file. Maybe it's going to have the game in there. I don't know. Right, 8 megabytes. Let's just say 128 of all the megabytes, right? Tune it later. Not a big deal. Alright, so we have what? So we've got a crash here. Here's the stack trace. Apparently it's trying to rasterize outside of the... Right, we didn't... Oh. Did we initialize the glyph cache? And one, it's not zeroed. Wait, do we care? Does it need to be zeroed? Yeah, I wonder if it actually needs to be zeroed or not. We can... Yeah, we have initialized the glyph cache data here. There's something clearly wrong. I guess we can put a breakpoint. Okay. And the first one is a rectangle, 0 ID, width height. It's got some X and Y's on there and it was packed. It's got scale. Ooh. Sorry, we should have added here. What was past me thinking about? You take away on the width, obviously. Right. Oh, we hit the trap. Left the trap in there. Cool. So apparently it's booting up. We're not seeing anything in the glyph cache yet because although we've rendered it on the CPU side, we've not uploaded it to the GPU yet. So that's the next step. What I want to do is actually just recap what we've just gone over, what we've just done. So text draw. Okay, so in text draw, now we have some code in here just to try and get some of the glyphs into the glyph cache. We make this styled glyph, which knows what fonts we want for this glyph. What is the glyph index inside this sort of font file? What is the glyph index? And what is the line height? You know, so one again. Right, so we've inside text draw, we have gone over all of the glyphs, and we've added this code, which wasn't there before. So we make the styled glyph, we zero it because there's some padding bytes and the whole U64 is going to get hashed, right? It's just a bunch of bit fields. So we put the font in there, and then we put in like the glyph index, which is a glyph index into the font file, which we can use with this function here in STB TrueType. And then the line height is the number of pixels for the line which determines the size of the glyph basically. So we try and insert into a hash set, and this is for all of the style glyphs that have been added this frame. If it's newly been added to this hash set, then it will go into this if statement and then try and put it into the style glyphs for the glyph cache. And if that one succeeds, it will add it into this styled glyphs that were added newly this frame. Oh, wait a minute. I think I want to do that one again. I was reading that too literally, but I get the idea now. I get the idea. Okay, so we've gone and added some more code to this UI text draw. So we go over all the glyphs in the string that we're trying to draw, and this is the new part here. So we've got the style glyph. We zero the style glyph because there's some padding bytes in between the bit fields. So these are all bit fields here, and it's going to get hashed in the hash set. So we just zero all those, the whole thing. We put the font in there. We put the glyph index in there, which is a glyph index into the font file. So you get that using this function in STB TrueType. And then this is the line height. So this is basically the size of the glyph. So what we need to do is we need to see if this glyph has been used, or if the styled glyph as a whole has been used this frame. And if it has, we just skip past here and just try and render it. If it hasn't been used this frame, we're going to go into here and see, hey, is this thing in the glyph cache? If it's not in the glyph cache, we're going to put it on this array and say, this style glyph is new, this frame. And if not, we're just going to say this thing has been used this frame. So regardless, it's been used in here. If not, it's just been newly added this frame. Yeah, so this is the text draw change that we've made for now. Right. So I also want to recap the end of the frame code. Right, so now at the end of the frame, we have these two arrays, which is style glyphs that were newly added this frame. And then there's another array, which is the style glyphs that are in the texture cache, and that will use this frame. So what we try and do, we've got two attempts here. We loop, and we say, we allocate a bunch of rectangles for the new glyphs that have tried to be added to the glyph cache this frame. And we're going to go over all of those glyphs and try and make rectangles for those. You know, this could be way smoother. Okay, so we've at the frame end function, we now have two arrays. We have one array which is filled with all of the new glyphs that are going to have to get added to the glyph cache, and we have another array which is all of the style glyphs that are in the glyph cache and used this frame. So we just loop over twice. The first loop is going to go over all of the glyphs and build rectangles for them, for the ones that were newly added into the glyph cache this frame, or are going to be at least. Try and pack them into the existing glyph cache using the rectangle packer, STB rect packer. If all of them got packed, awesome. We'll go over and render all of them into the glyph cache texture, using STB TrueType again to do the rasterization on CPU, right? And then if that failed, we're going to zero the glyph cache texture, and then we are going to reinitialize the rectangle packer and say, you know what, start again. And then we're going to use all of the glyphs that are in the glyph, or that were in the glyph cache and were used this frame. So this will then do another attempt. So get rid of all the ones that were in the glyph cache and will not use this frame. Plus and it will keep the ones that will just use this frame, including the new ones. So it just goes around again, tries to pack them. On success, it's going to rasterize them, and it should always succeed. So we've got an assertion here. If it's not, try 0. It's going to fail. So this is now rendering them into the glyph cache. So now we just have to upload the changes to the GPU so we can see them in that texture viewer. Cool. That's good. I like that one. So I guess we can briefly mention the initialization code. No, it's just initialization code. Well, no, I guess it's got a key insight. Into it. We've got max number of glyphs, I guess. Should that be mentioned? Probably not. Yeah, maybe. Let's do it. Right, so this is the initialization code. We're just initializing some hash sets and some arrays, basically. One key insight is that we've got this glyphs capacity here. So essentially, we have our glyph cache dimensions is 2K, right? It's 2000 pixels basically across the X and the Y axis. We've gone ahead and made what is the smallest glyph that we want to render, and it's going to be 8 pixels big. So with this information here, we can calculate what is the maximum number of glyphs we're ever going to need, or that we can actually fit. So we can size our arrays accordingly based on that. So it's basically the dimensions divided by the minimum size for a glyph, and obviously squaring that number. Yeah, so we just have to make sure we put in the code. Don't render anything that's smaller than 8 pixels, then it should be fine. Cool, so we actually should put that in there. We should say, hey, what am I doing? What am I doing? So there's a line height. So basically the style comes in, right? If style, well, it's right here. Oh, there's DPI scaling as well. Apparently I've done scaling. If line height is less than I guess it's going to floor. That's fine. Right, so I've just gone and added that thing into here. So whenever you try and draw text now, it just looks at the line height and say if it's less than the glyph min height, then we just return. So we don't try and render the text then. That won't impact any of those arrays that we have. Cool. Yeah, so will we still have an issue with the glyph cache? Sorry, if you try and... Yeah, those arrays never get populated unless new glyphs get put in. Yeah, it should be fine. As long as you don't have overlapping text, I guess. Wait. Yeah, I still think it could overflow. Could overflow. Yeah, these hash tables won't overflow. But what will happen is you won't be able to pack. You can still overpack. That's the issue. You'll still be able to overpack, but I guess it's not really a problem to solve for now. If the game crashes when we're developing, then we can solve it there, but you can still overpack. Okay, right, so I'm just going to take a quick break, and then when we come back, we're going to sort out actually uploading this to the GPU and seeing it being rendered. Or we need to clear some hash sets as well. Thinking about it at the start of each frame. But yeah, BRB. Welcome back, everybody. How's everyone doing? How are we doing? So we forgot to clear some arrays and things. So that when we start the frame in the UI, you need to call some clears. So probably here. Core stack clear. I don't know what we're clearing exactly. Let's find out. Right. So all these this frame things. Probably something like that. Oh, that Mac OS. Some hot corners going on here. Oh. Oh. And this hash set needs to get cleared as well. Do I have a clear function for a hash set? That is a good question. That would be a right problem, will it? Ooh. Ooh. What would it take to do a clear? What's going on here? For a hash set, might not be so bad. Well, even for a... I think it might not be so bad actually. So you allocate the data. There's your hashes. Where's the... Yeah, you just have to zero all the hashes, right? But is it asking you for zeroed memory? Like, what's the... Why does this thing apparently work? Because it checks when you do the find. If it's empty, and empty is 0, right? Yeah. So... Yeah, I would be expecting... So yeah, clearing's quite easy. It's just a mem set away, basically. It's not as free as saying one integer, though. But it's quite alright. I would expect there to be a clear. Did I not put it in there when I copied it from the hash table? I think I'm just expecting it to be zeroed memory like a Wally. That's not good. Let's make clears. Hey, the Geeko. Yeah, I'm not doing bad, thank you. Not doing bad. How about you? Have you started recapping videos thing you said you want to do if you had time? Yes. Great time to plug that. So for those who want to catch recaps of streams, there's now little devlog videos, as they're called. So you can find them those on YouTube over that link there. So yeah, one way to help support the channel is just by subscribing, watching the videos, liking the videos, and all that. So if you guys like the content you see here, you can go over there and help me over there as well, and help more people find out about this project. Yeah, it's all over there. The Geeko. Thank you for asking. There's now about 11, so this is the 12th one that we're doing today. Yeah, so do like a clear. Hash set clear. So only do like a mem set. Awesome. Yeah, so I think are at least 3 a week. There's a nice steady flow that come in. They usually go up the next day, 5 p.m. GMT +1 usually. Hash set hashes. And the hashes are what? They're 64, aren't they? Wait, is this just a U64? Yeah, sweet. There's not void. So I can just do a core 0 element many, passing the array. How many? How many hashes we got? Key capacity. Worth. Sweet. So it's that simple apparently. So let's make sure we call it here. because I think that could be an issue if we pass in non-zeroed memory allocations. Then we also want to make that function for the hash table. Because it's pretty decent. Entries capacity. Right, so just need to copy and paste that one, and then we'll be able to clear those at the beginning of every frame. We need to probably put some macro around it, actually, thinking about it. Bottom of initialization, we need to then call that lovely there, hash table. Yes. Sweet. So in the header file, we would just like to put a lovely define here and just simply what is it called? Hash, yeah, void hash table. Cool, we nick that, and we'll find clear void. Damn it. Table set. Right, so now we can use this. Clear some hash set. So let's close that. Oh, ooh. Clear that hash set. Cool. So we actually need to clear the hash set when we for the frame end. Here we go. Here when we reset the glyph cache, we need to actually reset the hash set as well. Cool, so I think let's just talk about that quickly. I think that's everything. Glyphs to patch. All right. Boom. Okay, so one thing that we forgot to do actually is when we start the frame for the UI, we need to clear out all those arrays and the hash set, the ones that have been built up this frame, because otherwise they're going to contain data from the last frame. And also, where we ended up packing those rectangles or the style glyphs into the glyph texture, if we fail to pack the new glyphs that have been added to the glyph texture this frame, and we try again, we actually need to clear the hash set, which contains all the style glyphs inside the glyph cache, so those could be added in again. Wait a minute, that also means we need to insert them. So this would then mean we need to insert, you just need to find or insert. Yeah. So this would then mean if you do this, and you say if try is equal to 1 the second time around. We're going to add them. We're going to insert you probably want to keep the rectangle around as well, not going to lie. We can change that later. So maybe this one becomes a hash table. Yeah. Okay, so when we start the UI in UI frame start, we actually forgot to put these clears in here. So we want to clear out all the stuff that we're building this frame when it comes to these style glyphs. So including the hash set as well, we want to clear that for all the style glyphs that we used that are going to be used this frame. Reset them so we don't have any data that comes from the last frame and accumulates and causes problems with the logic. One thing also that we changed is when we try and pack those rectangles or pack the glyphs into the glyph texture, in the else statement, when we restart the packing from the beginning again, you know what, one more time. Gonna be smoother. Right, so when we start the UI from the beginning of the frame, we forgot to clear out some arrays and clear the hash set. So what's happening if we don't do this is it'll just accumulate some data and the logic is just going to go bust. It's just not going to work. So we also added another hash set clear here when we have tried to pack all of the new glyphs into the glyph texture that were added this frame, but ended up filling up the glyph cache, so we need to restart again. So this means we need to clear the hash set that simply keeps all of the style glyphs, that keeps note of all the style glyphs that are inside the glyph cache. And then when we actually try and render or like rasterize those glyphs into the glyph cache, texture itself, we need to say if this is on the second try, you actually need to make sure you insert that style glyph into the hash table. So the next frame, when we look over all those glyphs, it doesn't see it as a new glyph to go in into the glyph texture, and then it will just add multiple in there, which is not good, right? So yeah, that's pretty nice. Right, so that's good. Now the next thing to do, so let's just make sure it runs. Ta-da! Now what we want to try and do is take the pixels that we've got on the CPU and put them on the GPU so they show up in here. Yes. So how does one do that? So we've got a 2000 by 2000 basically, right? 2K by 2K texture. You don't upload that every frame if you don't have to. It's 4 megabytes, and we could be using those megabytes to do other things. So you want to only upload the changes, the new glyphs. Furthermore, you don't really want to upload one glyph at a time because it does a bunch of different copies. You should really group them together. So what we're going to do is we'll take the bounding box. So ideally, it should just pack. A couple of rows or something like this. It shouldn't, because we don't free individual rectangles, we always repack from the beginning again. It should ideally just be a couple of rows or something, right? It should never try and... It should never put a rectangle in two different corners of the texture. That would just be pointless. We'll see how that happens later on though. So the best way to do it is probably going to be like, so we need some UI API, which is going to get the actual pixels. So U8 glyph, I guess we could say const, right? Glyph texture. And then we also want to be, so that just gets the pixels. We also want to be able to get the bounds of this, you know, we want to be able to get the bounds. So we could just say, upload min upload max. So you get the min and max, and if any of those differ, then we obviously want to perform an upload. So how do we calculate the min and max? So these are just going to be some min and max boundaries. So these are just going to be set to 0. Well, because you might have not added anything. Yeah, so you've probably set them to, yeah, max them in, something like this. So you say, every time you go into here, GUI.this dot equal U32 max. Then this would be a max we set to the min. So all you're doing is every single time we actually render something in, we are going to simply say U32 min U32 times 2 with the minimum on here. So the minimum I think is XY. I think it's bottom left. I think it's sensible, right? So I think we just construct an XY vector like that. Now the max is a little bit different. The max, you also take the maximum, and you're going to be using the plus W plus H for height. So I think that's sensible, right? And then all we have to do is return these boys and girls, and then GPU side simply upload the rectangle, right? But we're not going to do the uploading right away. We're simply going to print out some information and check if it's all true first, because I think the GPU will just crash and burn if it doesn't like the look of things. Where do we do the uploading buffers for the UI? That is here. So we're going to go ahead and get some things. So here's the texture, all the pixels. Here is the min and max bounds. Bounds min, bounds max. Right. So I think we simply just want to print out this information for now. Yeah. and then replace min with max. So let's see how this, oh, we didn't implement those functions, did we? So let's quickly do that. Easy peasy, walk in the park. And I spoke too soon. Alright, so this one is going to return GUI dot texture, glyph cache texture. This one's then going to return the glyph texture. The naming is a bit inconsistent. What do I call it again? Cache upload min, upload max. Cool. So in here, and these hot corners, I don't get to the desktop easy. Yeah, they didn't have Windows D or whatever. Maybe there is a shortcut on KDE to go to desktop. I just don't know it. Right, let's see this. Okay, so we've got the min-max bounds as you expect. No new glyphs are being added, right? So it's not shown. It's doing, the min is greater than the max. Oh, right, it's greater than or equal to the max. So there's nothing to upload. So if we bring up a new piece of UI, did you see it blink there for a frame? There it is. Cool. So here is when we actually need to do an upload. So it is happening. Yeah. Nice. So we've actually got a bounds there. It's only a couple of rows. It's only like one row. That looks of it. It's the Y, right? So that's quite nice. So that should be basically what we're looking for. A nice simple way of doing it at least. So let me quickly just recap that, and then we'll be on our way. Let's draw it this time. Let's wait for wine. Damn it. Cool. Right, so next thing we need to do is only upload a portion of the glyph texture that exists on the CPU to the GPU. So you could upload the whole texture every single frame, but the problem with this is 4 megabytes, and you could just be using that data for something else, right? That bandwidth for something else. So imagine if you have these in the glyph cache already. You're obviously not going to upload these, but bam, you open up some new piece of UI and you've got some new glyphs. It's going to then put some more things here, right? So obviously you don't want to upload each single glyph one at a time. That would just be a bunch of different calls to say, hey, upload this small thing and this small thing, and that's not good. So the way I've designed it for now is it simply just takes every single time you render a new glyph into the glyph cache on the CPU, it just gets the minimum boundary of that box and the maximum boundary, and then it goes to the next one, gets the min and max, and it mins it across all of them, so you'll produce basically a bounding box around all the glyphs that you have added into the glyph cache this frame. So obviously if it spans if you end up having some that span to another line for some reason, the box will actually go around this and upload empty space and this as well. But it's a very simple implementation, and it's just gonna, and it saves, it saves doing the two, uploading the whole texture or just a bunch of small ones, and it's just nice and an elegant, simple solution for now. Right, that was good enough. I think we can move on and try and bum 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 bum. Right, so as I was saying, when we try and rasterize those glyphs into the glyph texture cache, we clear out this min and max value, set the min to the maximum possible value and the max to the minimum possible value. And now every single time we rasterize a new glyph into the glyph cache, we simply just min that, the box lower left, and then we max the box top right to the maximum here. And then simply inside the UI API, we just have a way to get all the pixels for the glyph cache CPU side and the minimum max upload boundaries. Bum, 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 bum. Cool. So I guess what we're going to do now is do the uploading. So it's as simple as saying something like this. GPU upload texture ggfx.glyph cache texture ID. Then is there some things that we need to do? There's an offset and a dims. Right, so the offset is obviously the min. Bounds min.x, bounds min.y, 1. That's the offset to the texture. What are the dimensions? So the dims would be subtract bounds max and bounds min. So here's our upload dims. That's how many dims we got. MIP level 0, array layer 0. Boom. So shoot. Right, 2 seconds. Right, so that's going to get us a bunch of pixels. UI, sorry, U8. This is our destination pixels. So basically, we're simply going to copy. We're going to copy row by row, or yeah, you have to copy row by row. So you go for every Y. For every Y0, you're going to upload dims.y. And then you could do 1x at a time, but it's just bytes. So you're better off probably doing a mem copy, because it could be quite wide, and it's just quicker using mem copy for larger sets of data. So yeah. Destination pixels plus so there's an initial x offset, isn't there? So yeah, y times what's the width of this thing? It's upload dims.x, isn't it? Then we want to say plus the, there's no initial offset that we need to talk about actually. Destination pixels plus y. Yeah, I've actually not tested this out yet. Uploading into an offset should be fine. Destination pixels plus. So we're just going down each row basically, stripe by row. Then we're doing source pixels. Source pixels plus. So the Y, you need the overall Y. So it's bounds min dot y plus y multiplied by a row, size of a row. That is glyph, UI glyph cache dim. And then you got to offset by the bounds min x. Bounds min dot x. That's right. Yep. And then how much are you copying? So I guess you want to get your, we should probably label these variables as UA destination row, source row, and then how many bytes we copy in for this row. Well, that is simply just upload dims.x because each pixel is 1 byte, so that just works out fine. The crap is going on here. I need to be const. Rightio. Maybe that's where I had that. So let's try. Oh yeah, so you only want to do this providing that if all components are greater than, oh sorry, are less than bounds min, bounds max. Right, very nice. So yeah, if the min is less than the max, then we have stuff to upload. Right, so hopefully this doesn't destroy the stream. We'll see. Yeah, if the stream crashes, I'll be right back, but it should be fine. Right. The stream is still alive. Now. Of texture dimension, this big old number here. We've uploaded textures before. Oh, it's an offset. Whoops. Okay, so that's obviously wrong wording. Let me sort that out. Right, it's done a ZU at the end. Shouldn't have done a ZU. Offset plus dims. Yeah. Right, that's a good catch, at least. Try that again. Still alive. Right, let's open it up. And we have garbage. So they are being uploaded properly, and they're bloody small though. B, you can tell they're not correct. And the hash set is getting full. For some reason. 1073. What? So this one's getting full. Right, so my clear functions were not actually clearing out the count or something, it must be. That's problematic. Yeah. Okay, let's try that out and just see what happens. Right, so it doesn't fix anything. Let's just wait a few frames and see what happens. So we can see there's some kind of rasterization happening here. We can also tell that they're of a certain... Oh, this is color texture. Whoops. Oh, this is RGBA. Ooh, that's a problem, isn't it? Wait, once this engine done, then you're doing game dev with an engine. Wait, once the engine is done, then you're just doing game dev with an engine. Damn, I'm scammed. I don't know, there'll still be engine-y stuff to do. There's always engine-y stuff to do. But yeah, it'll get to a point where we'll be working on the game. That should hopefully be start of next year. Maybe. Maybe 1 year from now. I got an idea. I think I've got a plan now of how I want to do the rendering and yeah. So I think a lot of the R&D is going to come to a close soon. Whenever we get back onto it. Should be good. Okay, this seems to not be crashing. Yeah, it's going to be amazing. Just want to settle on how I'm doing these spheres. I've got an idea. I don't want to disclose it yet because we want to work on materials next. So we're making these spheres look good, and then we'll be doing basically BVHs instead of how we're rendering these spheres now. But yeah, it's gonna be good. Gonna be amazing. Yes, we actually made the mistake that it's the wrong format. Let's record that. Right, let's do one more code thing. Right, so when we end the frame for the UI, we're gonna, we get the glyph cache texture pixels and the bounds, and here we're saying if the min is less than the max, it means obviously we have stuff to upload. So it's gonna go ahead now and get the upload dimensions, say to the GPU abstraction, hey, I want to upload to this texture at this offset and this size. And get back the destination pixels to write into the staging buffer, and then the GPU will copy it later on at the start of the frame. And then it goes over every row, and it simply just gets a destination row and source row, and then it will copy it row by row into the staging buffer correctly. So we can now see in the glyph cache next to this uninitialized data, but there's a little row which has a bunch of funky pixels here that sort of look like characters. Now, what I realized is this format is RGBA unon. That's not right, is it? This needs to be a 1 byte format. We can't or can we have 1 byte formats? Or maybe we need to upload it where the RGB is, where the RGB is all set to a single value. I don't know. So we're just going to work that out now and we'll see what the fix is. Right, so in Vulkan, you can definitely get a 1 byte format, right? Um, so the thinking is, thinking is, just use that. Vulkan format R8 unorm. There's our boy. Is this my first personal project with such a big time span over a year? Well, I've done tons of projects in the past that have never finished that have been probably over a year. So no. But I did release one. It was my custom C compiler, and that took a year and 3 months. Working, in my spare time, right? So outside of work, I did this C to SPIR-V compiler that we're using in this project for shader programming. So yeah, I have done. This is the other project. Well, this is the project that I completed that's taken over a year. But yeah, doing personal projects over a year is probably not a good idea. Until you've probably done like a ton of throwaway projects. But yeah. Yeah. But yeah, this one's not throwaway. Put it that way. But yeah, how about you? How about you? Have you are you done any big projects at the moment, or are you just about to get to those? Um, yeah, so we can use this guy, right? Just gotta go ahead and. So I think we can just simply add. Right, so when we did the format, I don't think we need a storage format because I'm not going to be writing, it's just simply going to be sample from. So we just need to say this is a none. And then the GPU format simply needs to be a R unorm. So we need to go ahead and make this thingy. So let's just simply use it here. And then let's go ahead and find all the places where we use. Hang on a minute. GPU. I don't think there's any more in the H. No, good. So we want to do that for C. Right, so I guess we could say color. But then if it's color, we only want the alpha channel on. Or the R channel. Yes. Hey, game dev, try to be. Oh, good name. Try to be. Never looked into Vulkan before, but looks like OpenGL with extra flavor. Yeah, so Vulkan is like, it looks like a nicer designed API. The issue with it is that it's very verbose and also still hides what the GPU actually does under the hood. It doesn't seem like you can learn about GPUs just by reading the Vulkan spec. You have to sort of watch, or you have to read some documentation about GPUs or watch videos to learn about it. Yeah. So Vulkan's just really overcomplicated, and it's probably not the best if you're doing a solo indie dev project. Probably not the best idea to be using Vulkan. Unless you're planning on getting a job as an engine developer or want to boost your portfolio as a graphics programmer, then it's a wise thing to do. But you definitely should do some OpenGL first. Great work, I admire that. For me, it's very hard to stick to personal projects for so long. Fair play. Yeah. I think the biggest thing you have to do if you want to stick to a personal project is stay consistent with it, because as soon as you forget something, or you have to remind yourself, like, how does this thing work? That's a lot of like um, that's a lot of work that will basically just turn you off from coming back. So if you're gonna do a personal project, make sure there's some level of consistency. That is at least twice a week, I would say. Yeah. There's a lot of personal stuff that's going into this. You know, I kind of was looking at shaders and I was like, these things, writing shaders kind of suck. It's in a different language, and so I tried to make that. Oh yeah, and you can't really share code between the CPU and GPU and structures. So I tried to fix that problem, and hopefully other people think, this is a cool idea, and hopefully the rest of the world changes to do what I've done. That would be amazing, but I don't know how that would work out. But hopefully we start getting the same language we got on the CPU available on the GPU. 1 byte per pixel. Does Vulkan use HSL regarding shading language? It uses whatever you want, basically, as long as it compiles to SPIR-V. SPIR-V is a intermediate. It's a high-level assembly, which is a bit like LLVMIR. It's a high-level compiler assembly, so they can recompile it to any GPU. So the graphics driver will take that and compile it into GPU instructions. Right, I think that's all the bells and whistles we need, except for actually the Vulkan backend. So R8 unorm. And voila. Right, so that should be the necessary changes. The texture viewer is a bit of an... I wonder what it would be like. Let's see. It might put it in RGBA. Oh! Kind of looks alright. It's upside down. Maybe you want to turn it upside down. Yeah, I think we've got to put it in upside down. That's looking good. I think it's that the font is too small, so it's looking a bit... Yeah, that's fine though. I'm a secretly an NVIDIA employee. NVIDIA? Nah. I don't work for NVIDIA. I'm using AMD hardware. Why would I use NVIDIA? Why would it be NVIDIA? Right, this is decent. So I'm glad we're actually seeing progress. We just got to flip the rows upside down. Wait. Why are they upside down to begin with? At the bottom. Yeah, they've got to be still upside down. Right, let's recap that one. Yeah, for those who are new here, by the way, we do recaps of streams and post them as up on YouTube as cut down versions. So if you're interested in catching up on the previous streams, like we built the texture viewer, that's all recapped on the channel there. It's quite nice. And that's what we're doing here basically when I take little recordings. Okay, so I've added this GPU format. I don't know if you can see it actually, but this GPU format are unorm, so it's just a single color channel, 8 bits, right? So a single byte. We're putting that in the as the format for the glyph cache. So now, when we view it in the texture viewer, boom, what we'll see, it's all red, right? But at the bottom here, you're seeing the glyphs, right? They're all rendered in here and being uploaded, which is nice. There's a few issues. One, they look a bit weird sometimes, and this is probably because the line height is a bit too small for the font. I think it's only like, maybe not. Yeah, there's also this edge here, which is a bit weird. I think this could be the padding. The padding bytes are not zeroed or something like this. And also they're obviously upside down. So my textures on the GPU are by default upside down because I addressed with the bottom left, except for the surface texture is proper right way up. So I need to flip the rows when we copy them upside down. So they'll still stay in the same location, they'll just be oriented the right way up. So let's fix those issues now. Cool. So when we do the upload for the glyph cache texture, we are simply going to do our Y. So flip Y is, wait, what did I do that for? Is take Y, take 1. These change Y, flip Y. And voila, I think I should do. So that should be flipped the right way up. That's not right. Oh, so I didn't mem set the texture when I allocated it. Probably why. What? Row by row. I was doing this. Why did I go in on? Right, I'm flipping it on a. Okay, I flipped it in both. That was the issue. So I flipped once and I flipped twice, and therefore it cancelled itself out. So we simply just see that now, and voila. Bum, 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 bum. Amazing. Right, we didn't. Yeah. Oh, no, that's good, that's good. Wait, no, where's the padding? There's 2 pixel. Yeah, I don't think we're actually offset by the padding in there. How can a game not have an engine, or does it mean you're not using an existing engine? Yes, it does partly, but it means that this game engine is specific for this game. I wanted to try, I heard a lot of people say, it's a lot better when engine code is specialized for a game. So I'm just trying to see what people mean by that by trying it in my next project or in this project. So I can definitely see the advantages of it. So what it means is when you build a new game and you already have this engine code for this game, you could basically just copy and paste that over and just get rid of stuff, upgrade stuff, you know, that you want, that you don't want, or what you need to upgrade, you know what I mean? And then just tailor it specifically for that game. And if you solved a problem in the past, no, it doesn't have to be in a general library. It can just be grabbed, ported into the code base. Obviously, depending on how different they are, that could be either smooth or very difficult. But yeah, if your engine ends up being simple enough, then I guess it could be more to the side of easier to port. But the advantages that it does get is, let me give you one obvious example, which is UI. I've made this thing called a UI style. You'll see in here that it's got a bunch of like specific stuff about a widget, like a progress bar color or a slider bar height. And I got like a split view grip width and a tab header, right? If I was just to make a style structure, and you have all these bunch of different widgets, if this UI code was a library that anyone could use, you've got a couple of ways you can solve this problem. You have like a base UI style and you know inherit it, and you know, or you have a one style per widget, and you know, or you could do some sort of hash table thing where you can look up it via a string for some reason. There's ways of extending this, but by having it as a library, you have to make it extendable. Whereas if it's just built specifically for this project, you can just put it in as regular fields, and it's just very simple design. So there's lots of pros like this that arise when you just have code which is specific for your project. So yeah, that's basically what we're doing. Is your day job related to graphics, game engine development? Yes. I work as a graphics programmer, full time. Remote as well. So part of the reason why I'm doing so much graphics R&D up front is because I want to sort of help expand my, you know, it's one of the reasons. It's not the reason, but it's just good to have some side project there for some, you know, reference of stuff I've done outside of work or whatever. I don't know, as well as the stuff I've done at work. So it's good to have that there. You learn to see yourself. Awesome. What sort of things you doing? What sort of things do you want to do with C? Have you got some little small projects you're finishing, or that you're doing like a small quick project and throwing it away and doing some more? Because I feel like that's a good way to learn stuff, is just create code you just can well, not throw away, but you know, just move on from and keep there just in case you want to look back at it. Hey there, Alex. Do you use C in your day job too? No, we use C++ at work. It's kind of C style. Bearing in mind, some people do use more C++ E stuff, but the engine side is typically more C style, which is nice for me, so I don't pull my hair out during the day. You want to be a Windows developer? I'm working on my first Win32 app now. I'm actually hoping to do my first release tomorrow if all goes well. Oh, cool, nice. What have you got a link to anything you're working on, or any pictures or any details you want to share? Sounds interesting. Right. What am I doing? Yes. Did I put a marker down? I didn't talk about this, did I? Did I talk about this? I don't think I did. Right, let's put a marker down. Memory. Okay, so we've flipped the texture now, so we only need to flip one of them. So we've flipped where we write the destination row, and the source row still uses the Y offset. So, you know, we've just made this thing called flip Y. It's upload dims, take Y, take one, and we just use that to find the row. It's just the other row. So when we look at the glyph texture in our lovely texture viewer, and we look at the row at the bottom, bum, 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 the right way up now. So we have a bit of an issue here with this padding at the bottom. I think it's the padding pixels. They're not zeroed or something like this. That's something to look into as well. Let's go. Also, it was red, wasn't it? But let's fix the padding first. I think I just need a mem set on there. I think. You know. I think I was missing this. Yes, we allocate the glyph texture. Let's clear it all to zeros. I think that's the problem. I don't know. It could be the size of the... Right, still got the issue. Yeah, it's still got issues. Maybe the padding is fine. I think the padding is fine. No. Maybe. What is it trying to upload again? Let's zero it just in case. It's trying to upload... Right, how do we calculate the min-max region? Oh yeah, it said 1. Yeah, I remember when we printed out it said 1. So the problem is that upload min, XY has already had the padding in that taken off. We want the padding to be included in the upload. So it's the full rectangle. So I think that should be the fix. Boom. Would you look at that? So we've got a bit of padding, 1 pixel padding above, 1 pixel padding below. That's looking much better. Cool. Let's jot that one down. Yeah, the rest of the pixels are uninitialized, Cranston. And hey, welcome back. How you doing? Okay, so I found the bug where it looked like there was some padding data that was uninitialized, and that was because we didn't upload it. So in this upload min max, here was actually using the local variables x, y, and w and h for width and height. But we should be using the rectangle ones because the local ones are offset by the padding, so they're just not included. They were not included in the upload data. So now when we run this, what we will find is that the, you know, those dots at the bottom of the top are now gone. Obviously, this is all uninitialized data here still, but that's okay. So the next thing is to, yeah, it's showing up as red in here, maybe because this texture format is just one channel. Maybe we should just, you know, make it so it displays white, so it's a bit nicer, perhaps. Or maybe this is fine. I don't know. We'll see. Should we do it? That's the question. In the GPU, it's a private repo right now, but I can post a screenshot on my GitHub if you want. Yeah, like post a screenshot, send the link. It'd just be interesting to see what you're working on. It's fine, it's really basic. That's cool. It's your first C application, but it could be quite impressive. Your first C app. Yeah, been too long. Let's catch up on the stream. Good, thanks. A bit overwhelmed by widely different tech side projects as usual. I can imagine. See, for me at the moment, I handle 2. I've tried to do a third on the side, but it was one of those ones where I could work on it every other week or something, and then like I just end up like not doing it anymore because I can retain the memory of the project structure, so I just can't work on that one anymore because I spent too much time just thinking like, so where was I, and then like probably wasting time doing things wrong, so that one went to the side. But yeah, but yeah, 2 projects is good. Yeah, work on those consistently enough. I think if we're working on 3 is probably not so bad, and you kind of already do work on like when you work full time, there's lots of like little tasks you do, and those could essentially be considered projects because the code base is so big. You might go over there and touch that piece of code. So, theoretically, I do work on more than 2 projects, in a sense. Just how big they are. Tunnel window managers are nice, but I end up with the browser with some being able to browse syndrome with too many tabs. Fixing on anything, but sounds like a strategy. Your income is non-tech at the moment, which helps. Non-tech. Cool. Yeah. Awesome. Well, I guess you're doing something more away from the computer as well, which is, I guess, good for your physical health rather than sitting down at the desk all day. Sounds good. So should we change that color? Should it be red? We do that dispatch copy. When we copy to the texture viewer texture, should we say something about, we could put a flag in there. We can be like, oh, this thing is, so there's a visible channels. So that's saying, hey, do you want to show our RGBA? Yeah, I think we'll do it. It'd be nice. It'd be nice. So we want to add another flag, and we'll say like a single channel. So for single channel, how do we know if it's single channel? Question. How does one know that? Does anybody know that? There is the bytes per pixel, but it's not necessarily a number of channels. So we need a number of channels. Channels count. So let's go ahead and implement that. But yeah, okay, we'll just say like GPU. Oh my days, what did I just do? Resource texture format, sample format. If that is equal to 1, we do this single channel flag for the texture viewer when it performs the copy. So we're going to go ahead and make that lovely array. One, 4, 1, 1. So I guess it'd be black and white then now. Oh, interesting. Right. So single color channel, source, GPU shaders. Right, easy peasy. So if you got a single channel, we're going to simply say pixel B equal pixel R, pixel G, GB, there we go, R, and voila. Alpha would already be set to 1 because that's just the way fetch will do it, I think. At least. So let's give that a go. There you go, black and white. Amazing. So when we see our depth texture, it should also be black and white now. Ooh. What have you done? Be single channel. Oh, the sample. Wait, what's the sample? Weird. I expect that to not be red. Okay, that one's white. Oh, it's the occlusion. No. They should be. I'm confused why that happened. Is there an equals sign that's happening somewhere which is messing this up? No, it's ORing. Definitely a 1. Right, depth is only taking the R value, right. I see, depth should just say depth. Like that. That's why. Alright. Oh, hey Zandris. Oh, sorry, Zardus. Welcome back. I'm in computer graphics. Yeah, I guess, but not anything 3D. We're doing 2D texture rendering. But yeah, we're sorting out this glyph cache, gonna render some nicer glyphs rather than these horrible looking ones here. So we're just getting this ready. Hey Doro, do you have you checked out Red Eclipse? What is Red Eclipse? I'm not sure what you mean. Oh, recycle bin. Ah, so you can empty the recycle bin. And then you can open it up. Fair play. Right, okay, interesting. Is there a yeah, I guess you could do it manually if you right click it and say empty. But I guess you're just getting used around the API and just seeing how do you program in C. Nice. Cool. Yeah, it's a good idea to do nice little small projects you can just finish, throw away, and then reuse the code. Awesome. Yeah. I wonder what other C applications you can do. I posted a whole load of my Discord ages ago. I remember there's so many cool little ideas. But yeah, you want to do like Windows app development. That was a good start. Oh, I see. Actually working on depth map estimation using single images. I don't know if that rings a bell. Yeah, I remember. I remember actually. Yeah, we talked about the diffing, isn't it? I think. Oh, my wife has offered me a sub. Bringing back a Subway. How lovely. She's gonna bring me back a Subway. Right, what is the next thing we actually want to do here? Yeah, I just want to talk about what the color changes. Right, let's go. Bum 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 bum. There's a lot of markers down. Right, so we've changed how the glyph cache works. So now if you have a single color texture format, it's going to display it as a grayscale image. That's much nicer than just seeing red. So if we just take a look at the code, we've simply added a, if the number of channels for this sample format is 1, we're going to say, hey, this thing's a single channel. And then so when we do the copy of the texture view, copy of the texture into the texture viewer, copy texture, you'll see we check the flag. So we load the pixel, load the pixel out, and simply with a single channel, we'll just copy R into G and B, and it's just that simple. My wife doesn't know what Subway I usually have. No. Right. Chicken tikka. No, not chicken takeaway tikka. Chicken tikka. Wait a minute. The Italian herb. Italian herb roll. Right. Foot long. Chicken tikka. Obviously with cheese, right? Can't not have cheese. Then what for the salad? You definitely start with the jalapenos. Then you put the peppers on, followed by red onion. That's good, isn't it? Red onion. It makes a good sub. And then, obviously, I want Pepsi Max Cherry. Actually, no, I won't get the drink. Because I'll be up all night otherwise. That's no good. Just stick with water. There we go. Got a sub coming. Look at that. Right. What's next? We are rendering in there. Are those uninitialized pixels a bad idea? It is kind of annoying when you're looking at it though. It's looking fine though, isn't it? It's looking absolutely fine. Guess some of these are a little bit weird, but I don't know. Should I get rid of all this though? It might be a good idea. It's just a bit dumb. Should we dispatch a shader quick just to neutralize that area? We've got a texture clear. Right. So we're gonna say we're on the first frame. In it. Damn it. Ain't in it. Do it again. Ah, it's right here. No. Texture clear. Glyph cache texture. So do that first frame. There you go, black texture, and there's your. What? Right, it's uploading on the first frame, isn't it? Some glyphs. Do we want to allow it to upload on the... So, the clear is happening after the uploads. The uploads happen right at the start of the frame. That's not good. Can we delay these for a frame? Unless for the first frame we just say, hey, upload the whole texture, but that's at 4 meg. Uploaded. Maybe we could just do that. Why can't we do it? So what we want to say is like, we've cleared the texture. Yeah, so the texture has been so glyph cache cleared. So glyph cache cleared. If it's being cleared, then you obviously set this to false afterwards. And then you basically just say, well, those min maxes you made, these are just going to be 0 for min, and then max is going to be UI glyph cache dim. So you need to make sure you set this to true when you initialize the UI. Here. And then you also need to do the same thing where you clear it out here and restart again. So hopefully that works. There we go. No, same problem. Wait, what's the same problem? See, before we had this upload the whole thing. Wait, did we delete the... I'm confused. Let's not do this and take a look at the data. Maybe it was uninitialized memory in that space as well, but it looked like there was glyphs there. It's just weird. Right, there's clearly some characters in here, which are not repeated here. Yes, when you open up the UI, you get a burst of new characters. So I think what's happening is there's an extra... Extra what? Why would it... Oh, it's actually clearing, is it? It's entering here, probably. So if we get sig trap, then it means that it's actually clearing it out. And yeah, that's not good. Okay, we didn't get the sig trap. There's still uninitialized data in here. So I wonder. Okay, I think I'm doing something silly. Yes, we can't open or empty recycling bin from the start menu. You have to go to desktop. So that is the search menu. Cool. One click. If you enable sign. Nice. I prefer a plot twist to throw away. I do forget for over 6 months. Come back with new ideas and experience, make it better, learn a ton. I forget. Sorry. A long pause makes the jump in a personal project more visible. Right. So you can cement more in your head. I mean, like I'm prone to do this stupid stuff. That's for that future. Yeah, it's a good idea. Like, yeah, coming back to stuff, I guess. It just depends on the project, really. But yeah, maybe. As research as well. Yeah. Hey, Siba. Hey, man. Thinking about computer science for uni or cybersecurity apprenticeship. Do you have any? Do you have an interest, but sometimes feel dumb in comparison to other people with the same goal? I'm 17, by the way. I know I wouldn't be worried about being dumb. Like, as long as, it just sounds like you obviously have a problem with. Sorry, you have a feeling that you need to improve your skill, and it sounds like you're going to have uh the will to actually go ahead and improve yourself because you feel like you're not as good as everyone else. So that's fine, right? Doesn't matter. Like, there is always going to be someone that's better than you at something, and there's always going to be a lot of people that's better than you at something you've never done, or not done too much of, right? So I recommend just getting in there, and just getting the qualification, providing that is something you want to do. Just go and do it. Doesn't matter what anyone else thinks or how any much better other people are. You will just get better over time, and you'll probably have more drive than people who know everything, and achieve more. So yeah, get stuck in. Get stuck in. So why is this clearing? I don't understand. Like, so the first time it uploads the whole thing. The next time around, it should be uploading a portion. So what I would fancy doing is saying if when we do the upload, can I put a breakpoint in, right? So what I would like, crying out loud, what's this one? So I'd like to just, just get in there and see like, what is the size of all of these? Right. Breakpoint first frames, what we expect, should be the whole size. Yeah, whole texture. Okay, continue. So when I open this new window, now it's put another breakpoint. Look again. The Y is offset by 19. Oh, sorry, it's 19 pixels. Okay, okay. So what's the bounds min? That was the dims. Minimum is 261 in along the X, right? The Y hasn't changed. So, and what is the max? Right, 800 odd. So this looks like the second upload has come in. So right, it just means the first frame. Right, another problem. It just means the first frame actually didn't have anything in there. So what we're saying is, if the texture has been cleared and you've actually put glyphs on the screen, 2 seconds. Right. Oh yeah. So we're saying if the glyph texture or cache has been cleared and you've tried to upload something new, we'll upload the whole thing because we just want to put in those cleared pixels as well. Right, so let's try that out. And no. What's going on? Oh, I didn't do it in the. Oh no. Right, we're gonna look at it in Render-Doc because we've got a bit of an issue here where it's running loud. Right, so we'll capture it here and we can see what the texture looks like. Then we already know what it looks like afterwards. Let's just see it here. So, glyph texture. Right, it's got them in there. They're here. Interesting. They are there. So let's try that again. So maybe because I'm saying do it as a full screen size, it's kind of not, the upload code is actually a bit wrong. Oh. Maybe. Min max. You know what? There's an off by 1 error. I can see it. There's an off by 1 error. Let's run that again. I want to see the. Yeah, there's an off by 1 error somewhere. Let's capture this. Let's look at the glyph texture. That's so fun. Right, so what you got. Okay, yeah, they're in different places. For some reason, this one's down here. Bit weird. And that one's up there. Oh, because the min no. So this one is back to what's upside down. This one is also upside down but at the top. I think I flipped the wrong way. Yeah, I think I flipped the wrong. This should be flipping the source. No, hang on a minute. Not flipping destination. You should be flipping. It should be flipping destination, right? No, where destination is to go. Yeah, it should be flipping the destination. If you flipped the source. No, maybe flipping source will fix it. Yeah, it's actually up here. Silly, 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 silly. And these ones are down here. Yeah, something to do because they're like a right, hang on, I didn't know. So it's probably because the bounding box is multiple rows. So the first one is actually got a big Y on it. We'll upload. At that certain offset. Right, so we put it at the top of the texture. Yes, I think you actually need to flip it here instead. This would actually be your yes, I don't think I flipped it here where the offset needs to be flipped. And that should land at the top. It puts it at the top. Oh, good. Right, minus upload dims Y. It's a screenshot, it's very confusing. Right, so they're all going up there now. Top of the texture. Is that where I want it at the top left? Because I flipped it here. So we flip the destination. We'll go in the yeah. It's gonna end up being at the top, that's fine. Wait, is it okay? Yeah, I don't think we want it to work this way. It's got to work with the bottom. So we don't do any flipping. What's happening? Right, so they're all upside down and they land in here. But I just wanted to flip the row. But the problem is these parts here are copied at the start, so the whole thing is just copied in. And oh, why don't we render them upside down? Wait. Why are they rendered upside down? Because I flipped the texture. No, but what's the box positions? Yeah, no, okay, it has to be flipped. Yeah, I did the flipping wrong. Okay, right. Okay, let's record that. And then we can move on to actually try and use these things, I reckon. Okay, so we've cleared out all the uninitialized data that's in the rest of the texture, but also I fixed a bug where it's flipping it incorrectly. So on the first frame where we actually have some glyphs, what we do is we upload the whole texture that's on the CPU side. So that's these guys here. And then when we open up the UI menu, it'll just do the smaller copies where it just does this little segment here. So let's just see that in the code quickly. What you'll find is in the UI. This is at the end of the frame when we sort of try and rasterize more of those style glyphs and put them in the glyph cache if need be and have this min-max thing that we saw earlier. But what we say is if the texture cache has been cleared and there has been some kind of glyphs that have been added this frame, then we're going to say, hey, just upload the whole glyph cache and then set this cleared to false so it never does it again until we clear the glyph cache texture. Cool. Anything else I wanted to do? I think that's... That was the flipping as well, wasn't it? Let's do another take there. And if you take a look where we actually upload the bounds now, we forgot to say, hey, by the way, when you have your offset into the texture that you want to upload to, this also needs to be flipped. Otherwise, it ends up flipping it depending on the size, and it's just wrong. So that's why I was at the bottom earlier, because the size was only one row big, so it just ended up at the bottom. So we also need to flip the offset as well, so it ends up being correct, so now they appear at the top. Cool. Yeah, what's next? So now I actually want to try and use these glyphs and replace the actual horrible font. So here's this lovely horrible font. We want to place it for these glyphs here that are only for the glyphs that are on the screen, right? So they're all different sizes as well. Nice. There's a bit of a catch up. Also, this kind of sticks out from most fields that people start when they're like 7 years old. Don't feel discouraged. Mm-hmm. Yeah, that's true. Like, you know, if you're they had an earlier start, but maybe if they had an earlier start, it doesn't necessarily mean they stayed programming as well or stayed doing that thing. They could have just done other things. Yeah, as well. But it's fine. People will always be smarter than you. Doesn't matter. You can still make cool stuff. Um, Must be nice to have fun and goof around like a man-child while children are being invaded by missiles on the other side of the world. Ooh, tough one. Yeah, well, you know, I think you're kind of a very smart individual to be able to say this to me, you know. But anyway. Got another super clever person just pops into the chat. Oh, amazing. Anyways, I'm gonna take a quick break and go to loo, and then we'll we'll get another drink as well, and then we'll carry on with trying to be a man child and getting some text on the screen. BRB. All right, welcome back. Man children and women children goofing around. Rise up. Yeah, I know, right? The funny thing is that person who probably posted it also probably does absolutely nothing as well. It's like, you know, or even if they did, it's like, you know, what I'm for being a man child and goofing around when there's, you know, I don't know, lots. It's just such a dumb take. Like, obviously, it's really sad that things are going on the other side of the world. You know, there's things you can do about it, there's things you can't do about it. You know, some people choose to do something about it by putting a flag in their Twitter profile and being like, I'm doing the thing. But, you know, it's just bananas. Yeah. Hey, Master Agent, welcome. How you doing? Good to see you. How's the job hunting going? How the interviews go? Started at 20, now 31. Still at it. Oh yeah. 11-year streak. Yeah. Was only 20-year-old, no 6 degree. That's alright, no worries. People start later. here we go. You think a person concerned with the state of the world would also subscribe to Live and Let Live and Save Your Life philosophy, but apparently not. Right. Hmm. Yeah. Yeah, potentially, you know, it's just weird. Bananas. Hey, people are weird. You obviously get a lot of smart people, smarter than you, making comments. Yeah, a bit like that guy scored me on the comments on YouTube. I got this one at the weekend. This was one of those other weird ones. Today I've learned so much about computers I'd love to share with you all. Someone posted in my YouTube comments. So my title is obviously GPU API completed it, mate. And then this one that's just like, it's called an abstraction layer. Vulkan is the GPU API. Like, okay. Everything's an abstraction layer. uh, you know, and also everything's a GPU. I don't know, it's just the guy, man. Obviously knows more than me. Just weird. I passed the second interview at. You passed the second one at Funcom. Nice. Senior engineer. Engineer now. Technical home test. Never pass. I'm moving to. Oh yeah, whatever it's called. I know. Semming. Yeah. Leamington Spa or something, right? Yeah, that's it. Nice. Incredible. This sounds like good news. I hope the best for you, my friend. Right, how the hell we're going to do this? I've taken a screenshot of my screenshot viewer and it's confusing when I boot it up. Right, glyphs and things. So what do we got to do is put these here in these places. So we need the rectangles and we need to give them to oh, playground games. Oh, fair play. Uh, Unlucky man, but yeah, I hope this one seems like it's going well. So, what do I need to do now? Let's have a think. Let's close all the files I don't need so I get that out of my brain. So we've got these style glyphs. We basically need the rectangles. We need the UVs in the UI renderer. We need the UVs in the UI renderer. The UVs need to somehow get there. So we need the rectangle inside the glyph cache. So each glyph that's in the glyph cache needs a rectangle. So realistically, you're better off with a hash set, a hash table, which then gives you the rectangle. Oh, you really? I don't think you need it. Yeah, you need to go over all of the... Yeah, I think you need a hash table. And then this second part needs to be a STB. Well, an STB rectangle might be too much. It's got like a boolean in there. I think you just need the UV. You could probably pack it. So where's the UI draw glyph? Color glyph. Right, glyph texture UV bounds. We've already got a function for this. So that just does it based as hard coded, basically. So now we need to be able to say, given this glyph, it's different now. But yeah, so we push 2 words on, which is the UV bottom left and size. So I think we need to keep track of like these 2 things and patch them later. So when we try to render a glyph, we simply keep note of it and then patch it in later. Although most of the time we could probably just do the You want to patch them all later, or because when you do the draw glyph here, you already would have done the lookup. One that's done this frame, if it's new, goes into there. We've not really done the lookup at all. If it's, yeah. Okay, I think I got the plan. This is going really well. I've got a really interesting challenge as well for the home test. Can't tell too much details about it, but I can share that it's something fixing some naively implemented algorithms for systems in a large code base somewhere. Oh, the final where was unintentional and all that. Okay, nice, cool. Yeah. Interview tests are kind of hit and miss. Where I got hired, obviously, like coming up to 3 years ago now, I really liked that technical test. It's one of the best ones I've done. A lot of them are just generic C++, like, hey, make sure this person knows C++ and OOP. And it's not really flavored towards the company at all. So, yeah, it's really great when they have a sort of personal test, I find. You know, so it brings out the style and the flavor of the person they're looking for, you know. It's great. All right, let's do a little, take that. Okay, so we're back into this UI text draw, and what we're trying to do now is when we say draw color glyph, we basically want to be able to keep note of this glyph and patch in the proper UV coordinates later. So right now we're passing in like this glyph ID from ASCII. It was just a fixed bitmap font. And if you go to the implementation here, it's just basically pushing on 2 float 32 times 2s, one for the bottom left UV, one for the UV size. So we just need to fill in these guys later and just keep note of how to patch this. So we're just going to work on that code now. I can do that take again. Right, so we're back in the UI text drawer, and when we draw the color glyph, we're currently passing in this glyph ID, which is for that fixed size font. But now we need to keep track of the UV coordinates that are used in this draw command thing. And we need to patch in later, once we know that the glyph is definitely in the glyph cache, we can read it out, get the UVs, and patch it back in. So right here, as you see, it's pushing on a couple of words in the draw words array, and it's just got UV bottom left and the UV size. So we just want to keep note of where those things are and patch them later. So we're just going to work on that now. Right, that's better. So here is where we need to do the patching code. So we need to keep track of like, so we're passing like an empty UV. So we'll just say UV bottom left. I guess we'll delete this. Yeah, UV bottom left. We'll just 0 it. And then we work out, patched 0, patched in later in your frame end. All right, so the plan is to glyph text UV bounds. Here to do that. So we want to keep note of like, oh, this thing. Let's find out how we do. So we get the control layer, and we go, right, where's the next insert index? So this is where the where they're inserted into in the current draw layer. And we added this new glyph to patch thingy. So I want to say glyph to patch, and we want to do a core stack push. I want to say GUI dot glyphs to patch. Yeah. Now we're going to fill in all the bells and whistles. So styled glyph needs to be passed in here. It needs to be passed into the function still. Styled glyph draw word index. Here it is. Insert word index. And there we go. Then we need the layer. And that layer index is GUI dot draw layer. I don't even know actually. Draw layer index, okay. Rightio. So we just need to pass in the styled glyph. So UI styled glyph. Passing in that there, which is nice. And that's pretty nice. So now we need to adjust the function prototypes. And the clipping one also needs to change as well, because there's also, you can clip via a glyph as well if you wanted to for some reason. It's got that flexibility. Pros and cons about that. So we basically want to copy all this and put it in the clip. It doesn't have a pointer though. Yeah, maybe it could have just had a pointer, because if it has a pointer then it can work in both of these arrays. It's not limited to that. Yeah, let's get a pointer. Pointers all the way. So it's a bunch of U32s. You don't reallocate these at all, they're just there, reallocated, and so draw words. Draw or clip words. So we just retain a pointer to them and we'll overwrite them. So yeah. So then instead, that's just going to be, we want to get the end of the array. Does it get, so we want to do like a, I guess you get an insert index, right? So words. Right, I didn't pass in the style glyph there. Let's sort that one out. And the style glyph is not, doesn't even exist as a thing in the public code. So we need to make sure we bring that out. We'll just stick it in the core somewhere next to font. Seems sensible. Maybe we should. Nah, that's fine. Alright, so that goes in there. Alright, so this is the new and improved one. Let's just quickly go and change that. Yep. And it needs to be draw words instead of clip words. Okay, so now we've got those we'll keep track of those. Glyphs to patch. Glyphs to patch. There's I think there's two arrays. There's glyphs to patch. Oh no, it's patching all of them, isn't it? Glyphs to patch new this frame. Okay, we're getting rid of the new this frame one. We don't need it anymore. Yeah, we should probably clean that up a bit. Glyphs to patch. That's fine. Initialize and it gets cleared. Good. So, alright, let's record that. Okay, so in this draw color glyph, we pass in a styled glyph now instead of a glyph ID, and we simply just keep note. We get where we're trying to insert into this layer draw words, that's the insert word index. We basically take a pointer to that since it's going to be a persistent piece of memory. We don't have to worry about reallocations or anything. So we just keep note. We add to the glyphs to patch. So these are kept every frame, it's reset, and we just keep note of the glyphs we need to patch. And we put the style glyph in there, and the words, the pointers to the words where these UV bottom left and UV size will end up needing to go. So we're just going to now write the patching code. Cool, patching code. At frame end, where we did this, alright, there's this hash set thing, damn it. But yeah, so after we know they're definitely inside the glyph cache, we then go over all of the, there's a set there, so we go over all the glyphs to patch. Ah, shoot. So we go over all of the GUI.glyphs to patch. On the subway for later. Oh yeah. Glyphs to patch. Go over the patch count. Fish out a pointer. UI glyphs to patch. Patch. Yeah, let's just do the like that. Right, so now we simply just, when he's put out the rectangle, well, just pull out the UV. Wait a minute. Yeah, the rectangle will be, yeah, so you could probably do some U16s. A couple of U16s. So in a single U64, you can have it all in there. Probably would be alright. But yeah, so you could probably do. So in the internals, we probably need to store a glyph, a UI glyph rec, if you will. We know it can just be a bunch of U16s basically, where we have the XY width. I want it as width height because yeah. So I need to make a hash set, or a hash table for this type. So it's going to be with a UI glyph. Right, there we go. Most, if not all, good game engines start as a group of tools created for just one game. Yeah, it's probably true, isn't it? People start being like, oh, we need to generalize this or reuse it for this project. Wouldn't it be good if we could make some libraries, and then it goes into an engine? I can imagine. So, right, I think I want to record that now quickly. Okay, so in the glyph cache, we actually need to keep track of like the glyphs in there. Not just that the glyphs exist in there, but they're rectangle as well. So we actually need to change the hash set into a hash table for the ones where it's styled glyphs in glyph cache. So rather than just being a key, it's got a value now of this glyph rectangle, bunch of U16s because it's just a 2K texture, so it fits in that. XY width height, because what we need is the bottom left and the width and height. So we can make that UV with these pixel positions. But we still kept the hash set for the style glyphs that were added this frame, because we don't need any other information. Right, so let's go ahead and write the patching code. Now we have this rectangle. Patching code. Patching code. So you fish out the hash set, hash table, finder insert. Now you're gonna need like an is new. Wait. You need to pass in a value. Oh, no. You need to know if it is new or not. Pass in null there, we know. Yeah. Right. So you pass in null. I think you can pass in null there. If memory serves, we'll find out if you can't. But we don't need to insert anything in here because it should have been inserted all the way up here. So we should be able to insert the style glyph. Yep. This is the is new pointer. And then we can say if it's newly been in, if it's new to the glyph cache, then wait a minute. It's not been packed yet. So because it's not been packed, we leave it uninitialized. Well, we could initialize it to 0. It's more explicit that way. UI glyph rec. So we can actually just say, you know what? You know, filled in later once packed in UI frame. And right, so what we need to do is, while you're going around here now, you're going over all the style glyphs and actually rendering. So you always need to do a find and insert, and then here you would get the glyph rectangle, so glyph rec, and then what you can do, you don't really need to care if it's new. Yeah. Now you can actually pass. So what we want is glyph what we actually want is glyph rec x to be equal to x, y, w, w, h. So I don't know, maybe we could have pre-computed these into UVs. Some extra divisions maybe that go on. I don't know, there's a bunch of... You would be going... Yeah, for every single glyph that's rendered, you'll be doing a division, right? You're dividing it by... Whereas if you already pre-compute it here... Yeah. Let's do that. I changed my mind. We're going to pre-compute it. UV bottom left, UV dims. We should also rename that from UV size. It's not really a good name. Size means size in bytes in my code base. Dims means dimensions. Also meaning, you know, 2-dimensional basically, or 3-dimensional. And dim is 1D, right? But it means like a width or whatever. Or all of them are equal to that, yeah, that size. Yeah, specifically for texturing. Yeah. So we've done that rename. What are we doing again? Yeah, I want to record this. Okay, so I've changed my mind. I actually want to record in the bottom left and the UV dims here, so in UV space rather than pixel space. And the reason is because when we fill in the right, I need to do this again. It wasn't smooth. Right. Okay, so I've actually changed my mind. For this UV glyph rectangle, which stores the position in the glyph cache, I'm actually going to store the UVs instead of the pixel coordinates. It's just UV bottom left and UV dims. So it's two vector 2s there basically. And the reason is because when we at the end of the frame, when we go and populate, hey, we've got some new glyphs that we're rendering into the glyph cache. This is the pixel coordinates. We're going to change that for UV coordinates just a minute. But there's going to be some divisions here to put into UV space. So yeah, rather than doing those divisions, I'll do those divisions here once when they get inserted into the glyph cache. And then here when we do the patching code, it's simply just going to copy them rather than doing the extra divisions and things. So I'm hoping it's going to be better, but yeah, should be computationally better, but we'll see. What? Crap. What the hell am I looking at? Is there like a bot that's like, that's insane. This ain't good. Can I just ban this? Can we ban a phrase? No, you can't because you need a... What's that bot thing I have? This will do it. I should be able to change this. Kind of loud. Yeah, that's fine. This should be okay. I don't think you should be able to get any keys or anything. That'd be really dumb if they did that. Keywords. Keyback. Blocker terms. Here we go. Is someone actually live trolling? Damn it. Well. Great. We're someone who loves spending their time, clearly having fun. Yeah. There you go. Wow. Isn't that crazy? Thank you, Master Agent, and I'm Seabass. Appreciate. Yeah. I don't know, it's weird. I'm sure I'm not the first person to get that, so... Well, thank you guys. Anyway, back to where we were. So it was actually in the patching code. So, bottom left, UV bottom left. I didn't do floating point. Right, we'll re-record it. As a whole. So basically, right, float 32 times 2, we're going to be going ahead and saying, right, cast it into a float, x divided by UV glyph dim, glyph cache dim. So it's that easy, right? Then the y is just the same. Wait, sorry. UV dim is just the same. UV dim, yeah, just the same. But with followed by see, the problem with a followers only chat means that people can't, who knew can't, interact, but we'll see. I think that's all right. So what did I do? Okay, is that all fixed? Ooh. We didn't pass in the style glyph. All right. Yes, excellent. So I want to record that. Oh, I changed my mind thing again. Glyph rec. Okay. Crying out loud. Okay, so I've changed my mind. I actually want to make this glyph rectangle use the UV coordinates instead of pixel coordinates, and the reason is because there's actually going to be some extra computation that's going to happen over every single glyph we try and render, rather than the glyphs that we're just packing into the glyph texture of this frame. So now when we pack the glyphs into the glyph texture of this frame, we go into the hash table and find or insert into the glyph cache hash set, or it should be hash table now. But anyway, and here we put in the UV coordinates, which is basically just the XYZ in pixel space divided by the dimensions of the glyph cache. So this division here, or these divisions, would have been done for every single glyph being drawn on the screen, but now it's just happening when you render it into the glyph cache. So it's a little bit less computationally heavy. So there we go. Cool, so I should actually just rename that to a table quickly. There we go. Yeah, so now let's do the patching code. Dead easy, right? You simply do the find. So patch styled glyph, right? You get back the glyph rec, and now you simply just pack it in there. So patch. See, where does all the draw layer compression stuff happen. Yeah, don't worry, this is fine. That happens later on, after frame end. When you get the draw, yeah, the draw erase copy, it does the unpacking there. So this is fine. So we patch. Yeah, we're in frame end right now, which happens up here. So patch words 0 equals patch. So then we've got to cast the bits. So it's patch, I don't know, glyph rectangle, UV bottom left, and you'll do like a bits from EU32. So it's just a bit cast. Words 1, and then so the GPU doesn't know. It just reads the words out in an, it's trying to render like a glyph, and there's a bunch of U32s that just come after that sort of enum, and it just depends on what the enum is saying. And this one's saying it's a glyph, so it knows that the X is in here for the bottom left, and it's just sort of reinterpret cast it. So it does that all in the shader. Reads that manually and does the casting. And UV size, UV dims. Alright. So that's the UV thing done. The problem is it will render from the wrong texture. Okay, so this is what the patching code looks like. We just go over all the glyphs that we want to patch. This is every glyph we've tried to render, this frame. And we simply get the patch pointer, get the glyph rectangle by finding it in the hash table, and then basically just doing a reinterpret cast from a float into an integer and just packing it into the words for the X, Y, and the width and height. So now we've got all the draw data hopefully done properly. We've now got to actually change the shader so it tries to load from the glyph cache instead of that previous font texture that we was doing before. Alright, so if we go over to GFX shaders, we're going to find the word glyph in capital letters. Here's where I was talking about before. It does a switch statement on the type. That gets put in the word before all of these words, and here's where it loads them out. But I think here, yeah, BC font texture. First of all, what should I call this UV? Let me rename this from UV size to UV dims. So actually this is fine. Shader's fine. It's just when we dispatch the shader. Yeah, font texture, we'll rename it to glyph cache texture. Right, so that's all right. The one that was the actual problem is hey Greenblade, how's it going? How you been? Happy Sunday. It's like Mac OS, what's going on? Okay, so we've now added, oh no, oh now do I keep having to say that, right? Yeah. Okay, so I've gone and changed this push constant name to now glyph cache texture. So the shader code just got updated. These are all the push constants going up into the shader as we do a dispatch on that. And we just got to change it to use the glyph cache texture ID. This is the one that we've been uploading to and seen in the texture viewer. So now hopefully that all just works. I've been good, been playing X Defiant. PS5 game, you say? That looks like Call of Duty. I'm not gonna lie. Like that, whole thing just is made to look like Call of Duty, guaranteed. The first-person shooter video games developed by Ubisoft San Francisco and pushed by Ubisoft. Published. Okay, so just an FPS. Is it like a hero-based one or it's an arena shooter? Fair play. Guess it's free to play. Yeah, free to play. Fair plays. Similar to Black Ops 2. Fair play. They're releasing a it's a new game. You sort of basically plays like classic Call of Duty. Nice. Yeah, Black Ops. Yeah, they're actually in Black Ops 6 now, I think. It's insane. So many Black Opses. Yeah, I think I played the first one. I didn't really play the rest because I wasn't really a fan of the futuristic. Like, played a lot of COD 4, World at War, MW2, then what else did I play? I played Black Ops. And then after that I played them a bit, but nowhere near as much. They definitely tapered off from about there. Got a record of the fastest growing game ever, reached 1 million in about 2.5 hours. Really? Ah. Definitely trending. What? Oh wow. I wonder how that compares to other stuff. Yeah, I not really played modern COD. I just definitely gave up. Especially when MW3 came out, I was like, man. No, it's not as good. Sometimes I just went too heavy into making it so complicated and the menu systems being so complicated. But yeah. Right, I'm gonna run this and see if the stream dies. So I'll be right back if it dies. Here we go. We're still here. This is a screenshot, but we're not seeing anything. But we can still navigate and find the. Right. Clearly the UVs are wrong, but we're not crashing the GPU. So I think they're at the bottom edge. I need to flip the UV, I reckon. So basically we can do something fun and flip it. How does one flip? So why would then be take height, something like that? I don't know. Wait. Yeah, I think so. Oh, that kind of worked. So we didn't get the... Yeah, I forgot we haven't got kerning. Or it's also just rendering it at... Kind of working though. This is great. Right. This is definitely... So we need spacing. Yeah, I don't know what the issue is, but it's yeah, I think it's rendering it at the size of the glyph, the old glyphs. But at least it's there. Okay. Okay, so I ran it and turns out it does actually work, but the issue is that it looks a bit weird. Like there's something wrong with like the spacing or the positioning of the glyph itself, and the space is also rendering as some weird thing as well. So yeah, it definitely looks a bit funky. But yeah, I did actually have to change one thing, and that is I needed to flip the Y coordinate of the UV as well because the texture was flipped. So I flipped the YV coordinate there, and so that's what made it work. Cool. So y is the position. Right, you've got the x offset and all this lot, isn't it, to deal with the yeah. You got the no. You should be able to take the whole glyph and just render it in there. I think it's the way it's making the size of the glyph in text draw. For crying out loud, get in there. Yeah, it's just saying line height and divide by 2. That's obviously not right, is it? So we need to get the box size. Alright, so I think I found the problem. When we do the text draw and we're trying to render the glyph, we put an axis line bounding box shape. The half dimensions of the line height divided by 2, so it's just making it a square glyph. So we need to get the width and height of the actual glyph and probably some offsets as well. So we're going to dig into the SDB true type and see what we need to do. Nice one. So that is so you got to, there's some do like some offsets, but I think at the bottom of SDB true type they have some example programs. There's an example, I swear, or is it the top? I forget these things. It might be the bottom of the header. Yeah. Wait. Complete program. This compiles. Single bitmap ASCII art. Right, so they've got a bunch of little programs. Yeah, so print hello world. Integration in your code base. Oh, sorry, this is the actual, right. Yeah, so we need this kerning thing. X shift. Yeah, I think we need to do some of this stuff. That was a whole bunch of stuff that's messed up. So you got the vertical met. Yeah, wait, we don't need that, do we? The ascent, that needs to put it down on the baseline. Right, you need to work at the baseline. Okay, that just renders it in place. Right, we don't need this. So it rasterizes it in place on the screen. But yeah, when we need to get the bitmap box. Subpixel. Yeah, the subpixel offset, I think. This is what we need. Yeah. Okay. Okay, so what's nice in the SDB TrueType library, just before the implementation of the actual code, there's a couple of little complete programs here. So what we're missing is these vertical heights, so these vertical metrics based on the font. So we need this ascent, and we use this to work out the baseline of where the glyphs actually go. And we need to also make sure we advance our exposition by how much the space advance by the horizontal metrics of each glyph. And then we also need to scale. Sorry, we also need to scale the kern advance as well. Wait, let's do one again. Right, so digging into the header of STB true type near where the, just above where the implementation actually is. There's a couple of example programs. So we need to calculate the baseline by using the ascent, which you can get from the vertical metrics of the font. Each glyph has some horizontal metrics like advance, and we need to use this advance and also get the kerning bit between this glyph and the next glyph, and add that kerning as well as the X position when we go over each glyph. Furthermore, we also need to get the bitmap box, the subpixel positioned one, and we need to use that to probably position the text properly as well. So we're just going to try and hook up some of that now. Okay, so I think we're in a bit of a problem here now, because I don't know if I have the... Wait, this is just positioning. No, there's no problem. No problem. So let's just get some of the stuff in there. So I need text. So right, so I didn't have the scale for some reason. Did I call that font scale before? Let's call it scale. F32 scale. Oh yeah. Font information. I guess you just get that from the style, to be honest. Oh. Style font. I guess I could just run it out. Right, font info. Okay, so we've got that now. We need the ascent. Got that, what that is now. It's an int. And the baseline is an int as well. So int ascent and baseline. So something like that. Baseline equals ascent times by the scale. Now let's cast it into a super lovely integer. Right, so what's new baseline? Where to draw the glyphs. Wait a minute, did we do that right? Okay. So we definitely need the... I don't know if we need the box. I don't think we need the box. I think we just need the horizontal metrics, maybe. So we get these boys and girls. There's an X cursor, so there's an advance. Left side bearing, I think that means LSB. Left side bearing. That's not used at all, is it? No. So X shift. I think we'll look into that in a bit, because I think that's subpixel positioning. We might want to do that, but we can look at that later. So we want to get the font info, that's for sure. We actually want to use the glyph version, because we already have the glyph index looked up. So there's a glyph h metrics. So we've already done the lookup here. Just going to reuse that there. then we get out the advanced and left side bearing. So with this information, we're still not fully there. You also need to prefetch the next glyph index. If not, it's going to be a bit of a bugger. Wait a minute. So we need to do the kerning. So let's get some of this here. So cursor plus equals advance times scale. So advance times scale. Then we need to also say if we're not the last character, string.size. Wait a minute. I guess we're only doing ASCII for now. If we're not the last character, then what I would like to do is calculate the next glyph. So we're actually going to get the glyph index here. Start it off as 0. This will be set here like so. And then we also have the next glyph index there. Wait. You always get the next. Wait. I guess we can say if wait, what am I doing? Or size is equal to 0. So at least you have yeah. So we'll load the first one. I guess we want to skip space characters maybe. Like if it's a space character, don't render it. Yeah, that's another thing. So glyph index. So here you want to get the kerning. Cursor.x plus equals scale multiplied by glyph kerning. Then you want to get the run it out. That's glyph index. Then this comes here. This will be the next glyph index. And then the glyph index equals the next glyph index. So delete all that. Font is font info, followed by glyph index and the next glyph index. Now we actually need to make sure that we say this is equal to string data index plus 1. For now, until we do UTF-8, that'll be something else. I don't know if we'll ever do UTF-8 to be honest, but maybe we will. So yeah, that should be the spacing and everything. Wait. We didn't do the box. So spacing will be better. The box, however, won't be. Huh? That is still wrong. Why doesn't it work anymore? So we're advancing the X cursor by advance. Glyph index is fetched here. It's cycled here every time. Oh, it's hard coded to 15. Whoops. That's still kind of wrong. I don't know. Maybe it's fine. We just need to actually do the appropriate. No. It's not fine. It's still on top of each other. Why? Is it the kerning? Is it really just adding on negative or something. There's also like a baseline I haven't taken into account. They're definitely not aligned right. The x coordinate is still just plain wrong. Maybe it's something to do with the sizing. Like if we just said, hey, this is equal to advance, then it's wrong, right? But does that look better? Wait, advance scale times scale divided by 2. Scale is like 0 point something, is quite small. Right, so that's actually looked better. What we can see is that it's squished, but it's not overlapping as much anymore. So it's definitely improved. So the size of the font is simply wrong. So we need to basically position it via like the baseline, and there's an example somewhere I remember seeing. STB true type example. There's a good one. Unless it's gone. There's a good example where it does it with the subpixel positioning as well. Yeah, this is it. So yeah, obviously it's not using glyphs, it's using code points, it's a bit slower, but still it's a good simple example. So the ascent and descent, also got the line gap. We're not doing multi-line at the moment, maybe in the future. Not a big deal, but we want to get the render character. Stride and offset is important here. Left side bearing time scale plus by offset. Right, okay. Right, so they end up getting the bitmap box because they need the width of it in there. Right, I think we'll do this. What is a BW? Right, it's the size of the bitmap that they're rendering into or something like that. Okay, so where's the baseline? Okay, it's the ascent and descent. So the ascent is the baseline. So the y is baseline plus this. Right, okay, this is good. So we need that C0, sorry, X0 thing. Yeah, this thing. Wait. Glyph. Okay, subpixel box. That's what we want. So, excuse me. Yeah, so we need to fetch this after the H metrics. And what we want to do right. So what we'd like to do is I don't know. I think that's good. So the width and height that goes into here is, these need to be multiplied by scale. So it's something like x1 take x0 multiplied by scale, and then x then y1 take y0. Maybe it's the other way around times, but yeah, that should do. Then divide by 2 because it's half dims and not, you know, the full-on dimensions. So we need the ascent. So where's the Y used in here? Oh yeah, the byte offsets and stuff. Right, gotcha. They're not doing the subpixel positioning here, actually. Interesting. So what am I trying to do again? Right, the Y offset and the... So there's an offset, was that? So local space offset, should we... No, cursor. The cursor.y is equal to ascent cursor.y plus equals baseline right. So I guess you do every one of these. Cursor.y equals rectangle min plus baseline plus there's a scale that's involved in here, right? Plus y1 times scale. I don't know if that's true. We'll find out. But at least we can tweak it around. So these, so we're not positioned the X correctly. Let's do that one quickly. X is advancing by left side bearing, maybe. See, the left side bearing is how you... Side bearing. Right, left side bearing is the offset from the center, or is it the edge of the character? Yeah, I don't know. I wonder if we need all these offsets. Let's just try this one for now. We'll see. Yeah, that just needed left side bearing apparently, and that was it. Right, that heavily messed it up. Probably because we're using the wrong box on the Y. I think it was a bit too high. Right, still messed up. Let's comment out the Y for a minute. The Y offset. Still messed up. The height is very small. I imagine these numbers here are... I don't know. Let's have a look. So x0, x1, definitely, yeah, bigger, greater than smaller type of deal. Oh, sorry, it's already scaled. Already scaled. No need to do scaling. Yeah. Right, it's legit. Ooh. Okay, so they're already scaled. Nice, that is looking better. The Y is still off though, can you see that? G is a bit high. So that's where that Y offset should come in. We've got the baseline. Wait, is the descent used? No, descent's not used. You use the descent, I guess, when you go down a line. Right, so clearly we've got pushed up too high, and also that Y is a bit weird. That should have been Y1. Still not better. Things are offset a little weird. So plus baseline. So I think this thinks you're coming from a top. Maybe I don't need baseline. Maybe I do. Might be top left. Right, the P's are not on the baseline anymore. And the Y's in that. So it might be something to do with like taking it away instead or something. Nope. Maybe it's take away baseline, take away that, or maybe a plus in there somewhere. Right, so what puts it on the right line? Does this put it on the right line? Like, right, so there'd definitely be an offset in different ways here. So I feel like having this thing is contributing. If I did a take away, they are kind of all on the same, except for the G is just way off. And they are pushed a bit too high. Maybe I should look at the coordinates. Oh, thank you, Val. I appreciate it. Oh, I'm scaling again. Ah. I already knew that as well. Because I just removed it there. Thank you, Vala. Oh, perfect. Except for it is a bit going a bit too high now. So I think that's a plus. No. So it is right with the minus, but maybe the baseline needs to be minused as well. So we probably need to start from the top of the box. So maybe it's plus line height. Baseline. David style line height, just as an example. Does that work better? Basically it. Spacing's a bit messed. Let's take a screenshot. Because I got a screenshot tool now. Oh yeah. Right. So it's looking better. Definitely looking better. I'm not sure about left side bearing, but the beautiful thing is we've got the screenshot tool so we can compare it. The left side bearing is probably needed though, because look at this. What is that? It's horrible. So maybe we need a bit of left side bearing in there. So let's say, so also having a cursor is kind of pointless at the moment. I don't know. Yeah, maybe let's put the left side bearing on there. Quickly test it with a cursor. .x plus equals LSB times size by scale. And then I guess you'll take it away afterwards, just as a test. Right, so let's do an alternative screenshot. And we should be able to compare the two. So here's this one. That's the previous one we did. Here's the new one. They're both the same. Apparently, no change. Definitely looking nicer. Yeah, definitely nicer font rendering. What the crap is going on there? That's weird. Yeah, things are definitely off. Oh, we're not able to get the right texture size anymore. Texture size, that's not working. Yes, that is definitely better. I don't know what is wrong with the X though, because does the X need to be offset by X0 instead? I don't know though. No, it's way too much. You can see here the E. No, I think it's probably the same. I'm going to do an alt screenshot again so we can compare the two. Here's the original one that we did, and here's the new one. So with the X offset, it's brought things a little bit back in some cases. So that makes the spacing between E and R like a lot similar now. The kerning with the kerning makes that similar. But I don't know. I got to compare it with like. In some ways, the new one does look better. Like if you look at this one, things just. Yeah, depth as well. That just cleans it up a bit. But that E is still a bit too much. Like, why did that E not move if this E moves? It's a bit weird. Mm, 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 mm. Glyph 1, glyph 2, right, that's okay. I think that's... Yes, I think we'll keep this offset, but I don't think it needs to stay, because if I change this... Yeah, I think the... So if I do the... If I just do regular F12, now open up the texture viewer. So I got rid of the first changes. So here's the one from the last frame. Yes, added way more spacing to it. I think that's wrong. Made it a bit wider. Yeah, I think we should basically something like that. Yeah. I was thinking about that. I just, yeah, I'm not. Am I using it in the same? I don't know. Am I using the same font? That's a good question. Wait, it's in my. Obviously, it's not my NeoVim config. It's a terminal thing, isn't it? Yeah, I forgot the shortcut to get the settings up. Control Shift M. There you go. Liberation Mono. Excellent. Thank you. Yeah, that's a good idea. Let's do that. So, right, what are we trying to compare? So is that sphere? Oh, there is the space between it. You can see it. It's the R, it's just a bit short. Oh, nice under closure, yeah. Thank you, appreciate it. Yeah, you can tell there's the extra space there by the looks of it. I think we've got it right now. Yeah, under closure. If you want to, I've started doing basically recaps of streams now. So if you're interested in catching up on the texture viewer work, because that texture viewer is quite new, and as you can see, it's quite handy. So I'm glad I spent the time and did it. It took a couple of weeks, but yeah. So that's on there if you want to get a recap on stuff you've missed. But yeah, we'll be getting back into 3D stuff soon. I'm gonna redo this, but we're gonna do materials first to make these balls look good. Because right now they're just a shade of red. Awesome, thank you, thank you. Yeah, so we're a bit off still. Like, is this left side bearing we're missing? Like, oh no, it's the texture size. The texture size is just wrong. Yeah. Right, let's recap this. Wait, have I even done anything to do with... Oh yeah. Right, we'll recap this code. Not the code as well. Do some... Oh. Here we go, here we go. Okay, so now we boot up the game. You'll notice the text looks far better now. Still a little bit off with some of the spacing and that, I think, but it's definitely better. And if we change over to the texture view as well, we see it's also a lot nicer just to read. And we've taken some screenshots and been zooming in and just comparing previous, things here. So the texture view has been really handy. So let's take a look at the code on how we position these glyphs. So when we do the text draw, we now sort of get the scale and we get the vertical metrics with the ascent, and we calculate the baseline. We go over every single glyph, but we first of all make sure we get the glyph index for the first character, and we then do that style glyph hash table thing, but this is the new code here. So we get the horizontal metrics, which gets us the advanced and left side bearing. I've not used the left side bearing yet. We're going to see if that needs to go in there. But we also need the bitmap box, so the X, Y, and the index Y basically, on how to position this correctly. So due to the way I've do my bottom left positioning, I've had to take the where we want to draw it on the screen at the bottom left, add the line height, take the baseline, and then take this Y1 as well, and that puts it on the line correctly. And then we calculate the width of the box and the height of the box, and that's the half dims. And then we also offset the cursor X by X0 as well at the moment. And then when we advance the cursor to the next glyph, we scale the advance. And then if we're not the last character in the string that we're trying to render, we get the next glyph index. And then we use the kerning advance, passing the current glyph index and the next one, then we advance the cursor by that and make sure that the next glyph index is set to the current glyph index for the next loop around. Cool, that's really good. I like that one. Man, we're 42 markers. I guess I've done a lot of retakes. This might be another long one actually. It's a Sunday. Slightly more time. In my code, I'm also ignoring the left side parent. I just use advanced time scale, but I'm using right. Noto sans font and render glyphs as an SDF variant. Oh, okay, fair play. Thank you. Yeah, I've never used it before. I think I forgot why now. But yeah, I remember doing it in the past and I didn't use it. So yeah, we'll see. Yeah, what do I want to do now with the I want to improve the yes. Right. These. Right, so one thing you'll notice is that some of these things actually offset a little wrong. And what's happening is that my understanding is at least, is when we compute the size of the text widget, if you will, it's being computed using the old system. So we just need to go ahead now and make it basically use that same sort of like advancing code and calculate the size of the widget automatically. So text size or dims? Inner text dims. Here's our boy. So this one is wrong. So what we actually want to do is grab a lot of this loop code here and just not do the rendering. Huh? Right. Oh, I've already done that. Nice. 2D monospaced fonts. Okay, so I think we basically take the final cursor and wait, where's that? Was rect. Ooh. Right, cursor is just default to 0. And I think we want to. What's the line height doing? I didn't copy that, did I? SDF fonts do not have sharp edges. That you need MSDF. Yeah, I'm already a fan of SDF fonts too much. I think they're a you know, they definitely have their advantages, but I think what is better is if the Bezier curve data is directly used. You don't see many people doing that. I think that the pre-rastered fonts are probably best if you're just doing 2D text rendering, because they render to small fonts better. You know, they render smaller, nicer. But obviously the advantages of SDF is you know how far you're away from the edge, so you can do all the lovely shadow and, you know, you can make things a bit bolder and do borders, you know, outlines. But yeah, you can do the same thing with a Bezier curve, though, from what I understand. So yeah, if I ever do want world space text, I'll probably try and do something like that. Yeah, exactly. SCF and outlines. Yeah, so they go for world space text, and you don't have to use bitmaps. You can well, you can do bitmaps, but I think yeah, you can use in the shady you can get the real nice rendering in world space as well with it. This looks nicer. Return 0. So basically we've got to get rid of a load of crap. So we don't need to add a style glyph here. Yeah, we don't need to draw anything. We just want to calculate the advance. Just the advance on the X. Yes. So you're going to return, so now cursor dot Y equals line height. Then return cursor. So I think that's the adjustment we need. Right, things still not broken, and we're in. These are aligned properly, and so these now. Awesome. And so these, oh yeah. These are looking way better, man. This is good. SDFs do not need bitmaps, just sharpening based on the size of the text. Right. Took me a while to make it work correctly, I can imagine. Complicated shader code. Right, so as you can tell now, this is aligned properly in the middle. These are now aligned properly in the middle. And when you open this, these are aligned properly in the middle as well. So it looks far better, far more readable. And let's take a look in the implementation again. So when we use this text inner dims, we've basically just taken the same code you just saw, but we're not trying to draw anything. So we're just advancing the X, and then at the end we're just saying the Y is equal to the line height, and then returning the cursor. So remember, we don't have any multi-line text at the moment. This is just far more simple to do. Sweet. Yeah, I think, you know, is this revealing? Is this revealing anything like that's like a pixel away? I've got like 2 pixels. Is that not offsetting right? There's 2 pixels padding. I think when we draw this, wait. Where we draw text on this at least, what the hell is doing that? So there's a bit of text. Text has a border, so it's for the UI text widget. So this one does a draw. Right, but not using the draw rectangle. The draw rectangle's a bit bigger. So rect should have been offset by. Let's look at widget start. What's that doing? Widget start is yeah, it shrinks even by the border and then shrinks by the padding. So that is the rectangle that you get back out. So it should be positioning it correctly. So let's draw some fully opaque glyph things. We'll go into the shader for that. So instead we're just going to say it's white. So we should see tiles in that now. Yeah. So take a screenshot, pop open here. So we're only seeing a pixel. Right, but this is rendering as 3 pixels. And there's the problem. The box is actually rendering as 3 pixels. So I think my SDF box is off. I remember when we did the 2D rendering, yeah, we had that problem. Draw 2D, where I did the border. Draw 2D render. We do some SDF border thing. Yeah. So I think, let me take this implementation. Let's find where we do the bordered border width. Yeah, I think we need to plus 0.5 or something. Oh, minus 0.5 extra. Yes, I think when we do this sort of bordery thing, I think we need to plus a 0.5 in there, because that was a bit too big. Take another screenshot. Right, that's added a bit. It's added another one. Whoops. Does it take away? Wait, is that border width? Screenshot. Right, it's doing AA anti-aliasing. Where else do we do like a border? Not any other places actually. This is the only place. So okay. Right, so this is the AA. What does that mean? Am I... You can't be off by 1. Right, let's add 1. Yeah, that's correct, right? It's 2 pixels there. My concern is though that's not the fix. It's a bit weird. We should probably try increasing it to 3 pixels and see how it behaves. Maybe it is, right? So we increase the border as a theme. Border width. Here, so it's 2. Let's say it's 3 pixels. And we'll just play about with it. So screenshot, just get in there. Right, so now it's 3 pixels. 1, 2, yeah, 1, 2, 3. Got it obviously, yeah, 3 pixels there. So that's looking alright. Let's do 4 pixels. Screenshot. So the thing is you can tell that the X is moving in a bit, but the Y, the way we've decided to position that now is not, it's not good, right? The box that we're trying to render in is simply right, simply wrong. What's the issue with it? UI text. Maybe just text ID. If the rectangle you passed in has had all the padding and that removed, maybe instead we could say, hey, just draw a box here. Yeah, we'll do that. Yeah. Why don't we instead just say draw a box? Like a wet box. So let's just draw a solid box. Text draw. Whenever you draw a piece of text, we'll just draw a background or something. That's green or something like that. So given the rectangle, rect no radius. Let's do a solid color. Let's do color green or something like that. Yeah, let's give that a go. Let's draw that. Okay, so as you can tell, with a green box. Oh. As you can tell with the green box, it is positioned nicely. It's just obviously the way we are doing the positioning of the text is clearly wrong. We're adding line height. So that's alright, we can delete that. Debug code, that's good. The problem is here, it's not add line height, take baseline. Could it maybe just be add? What was I seeing that was clearly wrong? Right, it's definitely too high. What happens if I don't do anything? Oh, sorry, it'd obviously just be, right. This line is probably from the top. So your one is probably max y, take baseline, take that. Ah, there we go, much better. So that's sitting perfect. That's good. Right. That's looking a bit weird though. Oh, why is that one weird? No, that's actually fine. It would, you know, it's above there like that. See. All right, I think we've actually just completed it. I'm happy with that. I think you can do sub-pixel positioning to make some stuff look a bit better, but I think that's... Maybe we don't need it. I think that's looking okay. Amazing. Right, I'm just going to take a quick break and then we'll, yeah, we'll do some recordings. Oh, it's going to be good. It's going to be legit. Right, BRB. Awesome. think we've actually got a couple of screenshots, which if we're just going into here, I think, yes, there's an old picture. Amazing. So we can compare how terrible the font is and the colors with the new one. I can post it side by side there. That's really good. Amazing. Okay. Devlog 12, 19. So that means 20 we get to do some materials and things. That'd be interesting. Let's do some. That'd be amazing. Alright, let's round this one up. Right, that does it for Devlog 12. Thank you so much for watching, guys. So I'm really happy with the, where we got to. We got such a nicer font now. Things are far more readable, and we're able to scale them at all different sizes and just makes a really nice UI. So it's day 119 if you're interested in seeing the full VOD on the VOD channel. So the VOD channel is over there at the special, there's an actual channel for it. So the videos are separate from these devlogs here. You can also go to the Twitch link up there to get the schedule in your time zone so you can tune in live. And also there's a Discord if you want to come and hang out outside of the stream or the devlogs. And yeah, for those who support me via Twitch or Ko-Fi, those guys get access to the code, and you can also get access to the code too if you just follow those links there. And right, thank you guys for watching, and I'll see you in the next one. Boom. Complete it. So I think I'll upload a tweet with the comparison, because that'd be a good one. So what are we doing next stream, which is going on Tuesday, 6:30 p.m. GMT +1. There's one on Thursday as well at the same time, and Sunday is, is at 6. Wait, did I say 6:30 p.m. GMT +1? I meant 7:30 p.m. GMT +1 on Tuesdays and Thursdays, 6 p.m. Right, on Sundays, right. What are we doing next time? Bum 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 bum. Firefox. Manjaro. I've been outed. There's some cool stuff that people make, man. One day I will be like this. Does that look nice? Oh, anyway. We're going to be basically bringing PBR into the engine, physically based rendering. So we'll probably use this shader as an example. I just want to make my spheres look nice. They have some proper shading, basically. I'm not sure if I'm going for realism. I'm not sure if I'm going for realism, but I think having PBR at least will be a good way to at least. I think I want to have proper lighting, somewhat realistic lighting, but maybe not. Yeah, but maybe not like realism, if you will. We'll see. So I want to try and bring PBR in just to make stuff look nicer for shading. Yeah. So it's gonna be nice. Although we need like a cube map if we want to make these metals look good. So this has a bunch of examples in here, I imagine. I'm not sure what configuration they use in here. I've done a bunch of like research outside, so it'll be good to sort of see with what they use in here. But yeah, this is what we're going to be getting in the code base next time, and then after that, we'll be moving on to some proper scene rendering. I'm not liking the way we're currently rendering our spheres. I've got no idea. It's going to be good. Like, this takes 9 milliseconds to do this, and I think I could make it better. I can definitely make it better. But it doesn't solve the problem when we want to do proper lighting and shoot more rays. This is only a screen space optimization, and I think we'll just be, we already did a BVH before, a bounding volume hierarchy, and the results were somewhat similar. And I think it's just better if we just go back with BVH and make some other changes, which I would like to reveal when we get to it, because, yeah, secrets until then. But yeah, that's on the roadmap for the next few weeks. That's what we'll be doing. Materials, make these guys look good, and then BVH. And switching out to a new type of renderer. Still keeping with spheres, by the way. We're not ditching on spheres. Spheres are here to stay. Right, links and stuff. Discord, as you saw. There's a VOD channel. Catch up on the previous VODs. YouTube, if you want to see a condensed version of the streams and watch any past ones as well. Right, there's Don. It's right, Don. I've missed Don. Right. Thank you guys. Appreciate it, Alex and Annie. Oh, sorry, Anne. Thank you guys. Appreciate it. Have a good start to your work week, everyone. And enjoy the bank holiday in the UK. I'll see you all in the next one.